Yes, exactly. Here, dimension going to be by default. That's what it says. You need to change the measure. When you change sum, count, maximum, minimum, you have to change the measure, not dimension. Dimension will remain same. Understood?
Vertical application.
She will help. She will help. Everyone? Yes. Sorry. It depends on the data. Sometimes it prepares, but it wouldn't make sense.
Corona idea login idea. You just watch that.
Yes, who has? Okay. Go to sheet 1 already. Already you have the data inside. So you need to click on the new one. Maybe sheet 2 doesn't have it, right? Now you drag it out into rows and columns. Understood? Based on your requirement. Maybe depends on your requirement. Displays a graph. You can hide the other as per your requirement. Okay. Okay. Then in that case, you need to prepare a file, Excel file, and then upload it into Tableau and prepare that. It is possible to have it in Tableau Excel directly, but you need to know the codes. You need to understand the things. Anyone has any question? Forecasting. Okay. I will show it to you here itself. Yes. Sets. I will come to sets later. I have separate slides for sets. Yes. Sorry? Okay. Simple. Very simple. Just have to click on show.
Mine was default. I didn't do it.
No, you click on show me. No, it may not have been show me. You may have received it as it is. When you click on show me, it disappears. The complete picture will be seen. That's it. Have I clarified your doubt? Fine? No, please ask anything. Yes? Okay. Yes, you can. Right click on that file. If you don't want, you can remove it. Close. Click on close. Okay. Close. Yes. Correct. Yeah. Okay. In W, there are different options, but in this version, it's not available. Okay, you can hover over it and you will see the company name and revenue claim. Clear? Need my further help? Anyone else has any other questions? Can we go ahead? Forecasting. Are we running out of time? Right, so actually, I can give. Okay. No, use that segment to color. That's why color is. That's it. It's not a separate
And also,
content as well.
is there a way where we can see later which row and column is selected?
Yes.
Try on something new also.
Yeah, you can have your own data. You can upload into Tableau your own data. That's a very good suggestion. You can do that.
Always remember what you
How can we see which row and column is selected? I mean, just by looking at this one is gone.
Yeah, exactly. Looking at this, you have to know it. Is it? Okay. Only looking at this, you can make out. See,
Right.
See, some segment and segment was color. See, can you see the color symbol here?
No, that's fine. Okay, that's the only way. Right?
Correct. Because here it doesn't appear. Under columns and rows, it doesn't appear. Understood? Yeah. Correct. Yes. See, when it comes to graphs, definitely there has to be numbers. Without numbers, it would be meaningless. At least one column or one row should have values. Am I right? Otherwise, it will display value, but it wouldn't make sense. Correct. Okay. Is it possible to do descriptive statistics in Tableau? Good question. It is possible. It is definitely possible. I will come to that later. I have a separate procedure to be followed. You meant to say the average, mean, median, mode, how to calculate it. Possible. I prepared different charts of this kind as well. Have you done it? Everyone? And somebody asked me the question, descriptive statistics. Summary will give you some part of descriptive statistics. It's not complete. It's not everything. Am I right? It covers some minimum and median, and it doesn't cover more, and it covers count as well. How many values it considers? Okay? Yes, sir. Yes, click on summary. You would have changed
Any part,
click on any part. I will help you. Yeah, that's right. It happens for all those, right? Just check it. Right click on data itself. Is it happening for everyone? Yes.
Where is that data?
Okay. We'll come to forecast. Okay. Now we should give one. Forecast cannot be applied for any data. Please understand that. Whenever there is there is a set of two data. One is timeline, second is data, that is numbers. Then you can forecast. Otherwise, forecasting may not be possible for any set of data. Okay. How to get the summary? Right click and select the summary. Have you done it?
Right click where?
Right click on the data. Still executing. Yes.
Data visualization.
Yes.
We need information regarding students and classes.
Okay.
Not available.
See, some parts in Tableau may not be available right now, but company is still working on it. It's a new product which is evolving further. Okay. One thing. Second thing, we are working on Tableau Public only here. There is a paid version as well, which has many more advanced features. Yes. Exactly. Perfect. Perfect. That's what I was about to say. You didn't get summary? I will come there. Okay. You click on is there? Click on summary.
Right.
Okay. Summary.
There is
Yes. Excuse me. Excuse me. You did it right. The summary. Can you please help them as well? They are struggling. You got it? Okay.
right. There is a
You didn't get it. I will come there. Okay. Done? Who needs my help? Please raise your hand. I will come there. Yes. Got it? Yes. Yes. You didn't get it. What sort of data, first of all? For every data, there cannot be someone.
What is this also how it's no, that's this.
1
Please count the number of schools. This is 18.
Oh,
Something overall revenue compound.
Data points are
no,
missing.
no, no, I got that.
You do it again. You drag the data into columns and rows respectively. Then try again.
Is it only 81?
No, no, no. That is you are chosen.
How?
That things will chosen. That is selected for row and column.
Again.
Company name in this data.
It's a very far.
Are there only 81
Can you drag and drop what I said initially? Because for every data, there can't be summary.
Select calculate filter.
It may be a small chunk of data which may not have summary. For example, you have entire population and you took a small part, maybe Karnataka's population. It has only that. It doesn't have any other summary. Can you do it once again and check? I will come back later. You want summary?
वही सब प्रोसेस से
Yes. Yes. That's what I said. If you take the full data, whatever I asked you to work on, any files. No. So if you take only one segment of the entire data, it doesn't make sense. It should have some data, not just one point. See, for example, if you could take the population of India and you could take only Madhya Pradesh population. Sorry?
The overall company spending.
of net information.
This is I got on Excel.
So you got this.
Excel.
Yeah. See, this is a summary here. Sum is shown.
Just highlight as
Total. Exactly. Different segments total. Yes, I will come back. You haven't uploaded the data at all? An error occurred while communicating with the data source. There is something wrong with the connection. It happens, but you can see the data here. Okay, what happens? Can you check? Okay? Yeah, this is a typical problem. When you have problem with the internet, it happens. The data you uploaded is not complete. You are right. You will have to upload the data once again. Maybe it is required to close the application for you.
Okay, and then
Go to data.
from where?
No. Select over there.
Here.
Just go to data.
Okay.
Descriptive type. So it is not there. Go to Excel.
Yeah, enough.
Yeah.
Excel add-ins. Where?
File.
Okay, for every data, there can be summary.
Options last one.
Okay.
In this you can see the summary.
Count, sum, average, minimum, maximum,
This
and
one.
mean.
Yes, add-ins.
Clear?
Under add-ins. Go. Last one. Down. Go.
Okay.
Click. First one. Click the. Check the first one.
Analysis.
Yes. Okay.
And then this one, huh?
Okay.
Now, very important and interesting, how to export the data from Tableau. Is it possible to export the data from Tableau? You may make a lot of manipulation of data in Tableau and you want the data in other formats, maybe Excel or CSV files. How to do that? You just have to right click and export. Follow the procedure. Right click on the chart, select all, select view data and export all. These are the steps to be followed. Please experiment on this. Please try it.
data analysis. Here I want to with the just no problem. We'll select labels. There is some base statistics.
Perception about the data visualization. You can create a chart of any kind for any set of data. It is not possible. Okay, it is possible to create the meaningful charts for a prescribed set of data. There are conditions. There are so many conditions. Each chart can go to that particular area where you can see the chart. No. Show me your tab. Yeah, here. Click on show. Here, whatever is getting highlighted are the charts which are possible to predict for this set of data. What's the meaning of file? Correct. That's correct. This means to say that for each of the category, it is differentiating in terms of color. Can you see the color? Can you hover over it? Can you take your mouse here? Can you take the cursor? Can you take it? Yeah. Understood? Clear?
Data option here one.
Correct. What do you want to do? Okay.
I want it to
Right click, follow my procedure. Right click, select all, select view data and export all. Then you click on export all.
से दो नीचे यहाँ पे दो एनालिसिस फर्स्ट वन वर्जन थोड़ा अलग नहीं, then you have to highlight this file.
Select all and paste it to this. Can you check it right now? Select all, Control A, copy, Control C, go to your Excel. Control C, go to your Excel. It is possible, it differs slightly from one version to another. You can do it. Can we go ahead?
Now,
Differs from one version. Select all, Control A.
oh,
Okay, Control A.
doing all
Go to your Excel. Paste.
most of the essentially
Select all, Control C and paste it in place. Open the Excel and fix.
Again,
No problem. No problem. Yes. Have you selected all?
like to do some more.
Control C and go to Excel and paste. Okay.
Now wait. Go to this, say okay. And then the analysis are there. Data analysis.
The data will be there. Just go to Excel.
Data can
It is possible. Select all and copy paste
now
in Excel.
select this one.
It slightly differs from one version to another. Yes. Yes, sir.
नहीं रेवेन्यू वाला डेटा तो आप ये चीज है
Yeah, that's also possible. It is another way of exporting data. Given that everyone has on the same page. If it is differing, then it's difficult. Understand? Okay, I will tell you. You can click on new. That's another way. A little complex, but you can try it. You can experiment. And what I taught is the most easiest method of importing into Tableau. Okay, click on File and Open. Clear? One more interesting set of data which I analyzed through Tableau is Infosys stock price data. Okay, how many of you trade here? How many of you trade on stock market? Wonderful. 1, 2, 3, 4, 5, 6. 6. Okay. Number of values in this file is 65,806. Okay. Just open this file and have a look at it. I want to create different charts. Number one is monthly maximum closing prices. Second is number of shares. Third, number of trades and total turnover in rupees. Yes. What's happening? So try that. Try doing that. You can double click on that and get the data and drag and drop into columns and rows respectively. Yes.
Daily price.
Yes. Monthly, not daily. The original data, full data. Can you open the file? There are different tabs. Infosys data for pivot table and pivot data. You need to check only pivot data. What is not showing? Share price.
So these are all maximum for monthly. Monthly maximum price.
Check it here. Infosys share price. Oh. What particular sheet do you want? Now can you help him as well? You to name it, right? Now you got it? You just have to click on that file name. Yes. Yes. What's the problem? You will see all the prices, all the price details, and you can prepare different charts. Yes. Yes, sir. Click on
लूज कहाँ थे?
Understood, sir?
ये वाला।
Yes, sir.
हाँ।
What are the grades? Select all, right? View data. Then select all. Copy data. So go to Excel. Go to Excel now. Please go to Excel.
Was the highest. No, actually January to February was the highest. 6910.
Which file? File you should have no problem. Please submit it already. You can see it. Yes, you don't have to submit the money. Just control.
Just monthly max.
Some of the tools available for you to format the data before you input the file into tab view.
Basically, you upload the Excel file to this application.
Correct.
And whatever data you want,
Yes.
you can select all the rows and text for
Yes.
Excel file Excel,
Yes.
and you can
Correct. Correct. It's very simple. At the same time, you can modify the data as per your requirement, your objective.
Excel has to be there.
Yes, Excel need not be there. It is a handy tool. That's it. You can upload. I will show you.
So can I make the whole data set into this application and tab view?
I will show you. I will show you all the possible things in tab view. All these are the possibilities. Can you see Excel, Access, text files, Adobe, then statistical files?
So I'm asking if I can eliminate Excel and do the entire thing in this folder.
It is not possible. At least there should be one file.
Source file should be there.
Yes. You can't directly enter the data into tab. Yes, it's not possible. It's different from SPSS. Yes, it's not possible to enter the data for the first time in tab view. You will have to have some other tools like Excel and then save the file, upload it into tab view. Yes, sir. What you are not able to see, so. Okay, I will tell you. When you drag month into color, now, yeah, what you want?
After coloring, the labeling is good.
After coloring, label is gone. Thing is, there is a label. It is too small. That's why it's not accommodating it. It's not getting displayed. See, if it is bigger, it displays. All these are very small.
No,
That's why it doesn't.
after you do the coloring, even the bigger ones are not visible. That's what he's saying.
See, now what appears is a price. Price is quite long and it doesn't get accommodated here. That's why it doesn't get displayed. See, what you can do is you can try it again.
Very cluttered.
It gets cluttered and it's not possible to read it properly. Understood, sir? Correct.
It's already labeled.
Or you want particular index to be written here. There is a label option which I will come back later. Okay. See, you can go for two different. Here you can you can type it, ma'am. You can type whatever you want and it gets
Settings.
any more question? Yes. Three-dimension charts. It's possible. You need to experiment. Yeah. You have the three-dimension data first. This is not three-dimension. When you have three-dimension data, it's possible to create charts of that kind as well. Just try it out. Upload the three-dimension chart, I would say data into Tableau, and then try it out. Yes, you are right. He is perfectly right.
Data analysis. Let's select the floating price.
Some of the charts which I prepared for this data, and this is something which I always fall in love with. So colorful. Yeah. It is not possible to do this kind of charts in any other software. You can try out in MS Excel, but it's not possible to do such attractive charts in Excel. Even in PPT, it is possible to prepare the chart, but it's not that good. Yes, you have a question. Yes, it is possible to create, but it's not so attractive and beautiful. Yes. Can I go ahead? Dashboard is something which you can experiment further. And visual analytics is something which is very much related with business analytics. Yeah, you can experiment on this as well. When you have a lot of data, when you have big data, when you deal with huge sets of data, you can make use of this. Please experiment on this. Drill down and hierarchies. You can drill down the data from column and row, whatever you selected. There is an option to drill down. Can you check how to drill down the data? You just have to press plus symbol. It gets drilled down.
Like a tree.
Yes, you are right. Let us experiment on superstore data. And here you see year and sum. When you click on that small plus button, what happens? Can you do this? Have you uploaded the file? Please upload the file. Superstore data. If it is already uploaded, you can work on this. You just have to press the plus button and see the effect. What happens? You did it already? Wonderful.
For which fields you did? Year and sum.
Here. Can you see the small plus button before year? Just press on that. Okay, open the file and drag it into columns and rows.
Which dimensions have you taken?
Anything. You can take anything for your own example. Yeah. See here, the country may not have the plus button. So you should take such example. Understood? Yes. If you could do it, anyone needs my help? Yeah. You have these fields, columns and rows first, and then I will help you how to press the plus button to drill it down.
Which data points you have taken? I just want to see the
Okay, I took ear, hands up.
There is no year here.
Have you taken superstore data?
Yes.
Oh, you deleted some parts, you modified. That's why it's not C. You need to upload the original file.
It is the original file.
No, after working on the original file, yes, you would have modified it. Have you done it?
Yes, sir.
Yes, anyone has it down?
Let's try again.
Yes, data set modified. You saved it that time, right?
Now,
Can you go to your topic once?
okay, and click again, then will it again we will kind of get command. One level up. Yeah, yeah. Then some sales for customer. No, no, okay, that I got. But sales for customer. Yeah. Yeah, here.
Upload the fresh data because
Was this
why the same
data was?
okay, because here can be drilled down.
Drill down the one.
Whatever I am saying now. Yes, you're right. There has to be relationship between different fields. Correct, possible. See, unless you have relationship, it's not possible to drill down data, or you have to have the data which is related. Understood? Okay. Yes, sir. Sorry.
It's okay, you got it. There is some bigger you ready now?
Yes, right. Yeah, now, right. Forecast. Can you see forecast? Yes, show forecast. Yes, forecast. Okay, for this data set is possible, but drilling down is possible only for particular data set, not for everything.
Recommended one is there. This
See, when I drill down, this is how it appears. I can drill down further as well. Now I will tell you some important aspects. When you have this tool, Tableau, when you are given a huge data set to analyze, you can analyze them using this tool first. You don't have to analyze the data. It is possible to do this. And using data visualization charts, you can draw inferences. You can draw insights. And it is a sort of reverse process in analytics. Usually there will be data set and you will have to analyze the data after making sure that the data you gathered is correct. And when it comes to data, you will have to remember 3 points. One, it has to be accurate. Second, it has to be complete. And third, it has to be timely. So I always tell my students as well, you have to follow ACT principle when it comes to data. Accuracy, completeness, and timeliness. And Tableau helps you to make your analysis beautiful or attractive. So one more point should be added, that is B, ACT B. Accurate, completeness, timeliness, and beautiful.
What do you mean by timeliness? Accurate and complete?
When I say timeliness, it is something which to be discussed in terms of timeline, basically days.
Oh, okay.
See, when I talk about Infosys share price, it should be date-wise. That is timeliness. Is there any other question which I can address?
So you have added the Trump and the president's photo by showing that expenditures.
Okay.
How to add those photos?
Okay, that's a very interesting question. Unfortunately, right now the Tableau doesn't have that facility. I did it in MS Excel. Okay, in MS Excel you have the fill option. In fill you can upload the picture. I did it through that. You want to have a look at that once again?
Yes, sir.
And when you do such things, your report will be so attractive and meaningful. And one more important thing, if all the candidates appear there, how it's going to be? Will it be nice? All the candidates. It won't be, right? It will be cluttered and you won't be able to make out who is who and how much expenditure each candidate put in, how much money was spent by each candidate. It's not possible to make out. So it's better to take small samples. I took the top five candidates' expenditure on election in USA. In a similar way, you can take bottom 5 and how they performed in the election. And in the terms of Trump's performance, you can draw a lot of inferences using data analysis, using Tableau. There are so many possibilities. And he's making a lot of noise, am I right? So you can check it using Tableau. You can get the data from US website very easily. It's not possible in India to get such data, but from USA it is possible to get data. That's what I did now. Okay, is there any question? So what did we discuss so far in this session? We started off with Tableau, the origination of Tableau, how to prepare different graphics, different charts in Tableau, and how to modify it and finally how to drill down. Going forward, what we can do is we can create sets, we can create groups in Tableau and experiment further. Okay? If there is no other question, I will end this session. Thank you.
Thank you, sir. We are now going to have 5 minutes break. So we'll continue the session after 5 minutes. Thank you. One small announcement. Who are yet to do the registrations, please kindly do it. So, thank you.
Well, can we have the schedule?
Right.
We have got, what you say, we are entering the things. Basically, they are academicians. First need for the industry people they have huge sets of data sets, which they don't get to see.
Exactly. Very good.
So, if for my children, if my girls have to get exposed to data analysis, first they should be able to see the data. I mean, it is not the data that everybody is talking about. Those data sets. The course is done with doctors and industries.
Right.
I have all these papers, data visualization and I
What's
have
your program?
and
You can communicate. Nice meeting you and thanks a lot.
And it will take them SAS,
Oh.
but it is university version.
Okay.
I'm going to data visualization and data
Oh.
in the final year.
Okay.
On SAS and Excel, little bit for Tableau,
Okay.
and one small bit of Excel. So all this happens because of the people from the industry, not that we know. We just teach them statistics and maybe all the predictive, the theoretical aspects. Anything hands-on, Shishti handles the entire Excel, basic and advanced. But SAS are even are less in the econometrics perspective.
But definitely you can be in touch with me.
I mean, if you don't have cards, you are from
I know. I teach here. I teach
yeah, it's just opposite.
but I don't come there at all. This is maybe once in a year. I come. Yeah, you can call me.
Okay, and that's it's a new office.
It's not here. It's there for more than 2 years.
So,
And compared to yours, I should say I hate it. That's one perfect one. So you can contact me for it. Okay.
I know, once upon a time when I joined college, it was a huge bad and now these people, any meetings have come out there. But after the Shantri, I have wanted a motorcycle.
ಅದು ತುಂಬಾ ದೊಡ್ಡದಿದೆ.
ತುಂಬಾ ದೊಡ್ಡದು ಸರ್, ನಿಮ್ಗೆ ನೋಡ್ಲಿಕ್ಕೂ ಆಗಲ್ಲ. And ನಾವೆಲ್ಲ ಹಳೆಗೂ ರೋಡ್ ಬಿಲ್ಡಿಂಗ್ ಇಟ್ಟಿದ್ದಾರೆ, ಸ್ಟಾರ್ಟೆಡ್ ವರ್ಕಿಂಗ್. ನಾವು ಈ ರಾಶಿ ಬಿಲ್ಡಿಂಗ್ಸ್ ಎಲ್ಲ ಥ್ಯಾಂಕ್ ಯು ಸೊ ಮಚ್.
You're welcome.
ಈ ಕಡೆ ಒಂದು water bottle ಇಟ್ಟಿದ್ದೀವಿ. Sir, thank you so much for your laptop, sir.
My pleasure, ma'am. My
Thank you
pleasure.
so much. I hope mine will work now. Sir, now this is a session on art. Are we going to have another session? When is it now or some other time?
I think that they will break. My
Yes. Morning.
Someday we will.
Come for consultation. Let us work out something which is
So complicated. We would say. They're not going to come. There is no problem. They're not. As long as you're not going to. Yes.
This level they can manage. Yes. You mean our team?
2 years back. Oh yeah.
There's a John College, no?
Degree.
They have everything is biotechnology. Is it?
Interesting, right?
Welcome mail ಅಲ್ಲ ಬರೀದಿಲ್ಲ ಅಲ್ವಾ? But that's the ಇಲ್ಲ ಅವರೆಲ್ಲ 9 to 5 this you take this it's everything ಇನ್ನೊಂದು ಅರ್ಧ ಗಂಟೆ ಜಾಸ್ತಿ ಈಗ ಕಳಿಸ್ಬಿಡ್ತೀನಿ by lunch I'll send it to everybody. Good afternoon, everyone. I'm very happy to say that we have Mr. Vinayak Pai here from Mindtree, who is a data scientist, and he specializes in business analytics. Sir will now address all of us. After this, later when we break for lunch, if anybody still has any registration formalities left, may come back and speak to us. Also, during lunch, I'll send an email to all of you with the schedule for all the 3 days. Thank you. So, may I request you to please take over.
That will be start. I have not actually, I have my operations on interpretation and application rather than actually using it. I can tell you what I need in terms of chapter this year, we want it. I don't need to talk about functions here. I need to know the inside care, inference care. And I will tell you the invitation care also. The market doesn't work for normal.
Good afternoon. My name is Vinayak Pai. I am part of Mindtree's big data analytics team. We are a large team focusing on predictive analytics, big data, and cloud combined. That, as we discussed, we'll share some of the trends and why these groups are combined together. Before we start, I would want to ask you if you have any specific expectations from the next hour. Organizers have given me a topic and I have slides around that topic, but are there any specific expectations? Okay, thanks. What I would, you had some points?
Yeah, means there are so many algorithms and so many parameters we pass.
Yes.
What is the, means how can we know what parameter value will give me this speech model or like that?
So we will be covering the challenges in the discussion. I have a colleague of mine who's a senior data scientist who's on her way, and she will be covering some of the use cases that we have done in the industry and the challenges that we face. That question would be appropriate at that point in time, and she will be able to answer that. If I were to answer it in short right now, I would say it depends. However, that is not really a straightforward answer, right? So let's get there. Okay, I'm going to start off with 4 sentences, 4 words, 4 names, and it's like a game. We'll start it off here. I'll take your inputs. I'll not speak anything about it. I'll speak about those at the end of this session. How many of you think this is a relevant skill for the future? Neuroscience. Okay. Would anyone want to share why?
Analytical thinking.
Okay. Thanks, man. Anyone more?
Data sciences for the identification of consumer behavior.
Okay, interesting. Any other thoughts? Great. as I said, I'm not going to give my point of view on this right now. Maybe at the end of the conversation, we'll come back to this. Quantum physics. How?
Because nowadays computers have taken over news.
Okay.
That's the reason. Future is going to quantum.
Future is only quantum. Fantastic. That's very nice of you to put it that way. How relevant is this skill?
It's related to the first one.
It's related to the first one. Nice. Sorry, you had a point.
Sales depends upon human psychology. So
One
if
of
you
you.
analyze the psychology
Sentiments.
for your,
Sentiments. Yes. Thank you.
if you can analyze,
behavior we can.
Cognitive behavior. Yes. Thanks.
Behavioral targeting.
Behavioral targeting. Great. How many takers for this?
It depends on the previous one. Most important is out of all these.
Very important out of all of these things is what I hear. As I said, I'm not going to share my point of view on this. I'll hold it till the end and say why it is relevant. So let's then jump directly into the topic. This is what I'm going to be covering from a slides perspective. And the only way we can make it interesting is through interactions. Madam, have you planned any Q&A at the end, or can we have it as we go?
However you
Okay,
find it.
I would be comfortable
As
as
and
and when they have questions, please stop. That way it becomes a conversation. Somehow in the industry, we are used to this kind of conversations. I understand that in academics it's different, or maybe it is changed
Learning
nowadays.
styles, however you suggest.
Learning style, thank you. So, what's analytics? This is one way of looking at it. There will be multiple ways as we go ahead, but then setting a ground rule, when I speak of analytics, what do I mean by analytics? Because across the industry, many people think differently of what analytics is. And I was at one of the colleges last year, and I was talking to a bunch of students, and I said, what is analytics? And they were like baffled, they didn't know the term. It was first time for them. They're engineering third year students. So I just threw what I had in my hand at them, and asked, I just threw it at one, and he just caught it. I said, what happened? He said, you threw, I caught. I said, what happened? He didn't realize. Then I said, what you did just now was also analytics. So how does it work? We see an object, we see at the speed at which the object is approaching us. We understand that that object is coming my way. We give a motor order to the hand, which moves up, holds the object. And if you see, there's huge amount of analytics which has happened. And similar example could be when we are crossing roads. Ever compared the experience between when you're crossing the road alone versus when you're crossing as two people versus when you're crossing the road 4-5 people together? So there are different experiences at play, and when more people are involved, there are different experiences which could come, and even that could be termed as analytics. I'll just stop at that, not wanting to get into standard definition, but that is, businesses have been working traditionally with their internal data. Wherever relevant, they have been getting external data. For example, weather is one data that is being used nowadays. Census data is something which is being used nowadays, and all that data is brought in, put in one place. Models, predictive models are created on top of it, are derived out of it. Those insights are converted into actions, and based on the customer's reaction, we capture that, and the cycle continues. So this is what we would be considering as analytics for this discussion for now. So we jump into opportunities. I love this space because of the opportunities that are there, and many times I'm asked, how do I keep myself updated? And what you see over there is my way of keeping myself updated in this journey, because it's a journey. And these are some of the names. I'll be sharing some slides from what they have spoken about this space, and that is what helps me form my opinions on what are the opportunities in this space. We keep hearing, when we say analytics, we keep hearing these terminologies pretty often. There is descriptive, diagnostic, predictive, prescriptive. Descriptive and diagnostics look at historical information and try to figure out any trends in the data that is there, and that is traditionally called as business intelligence. Even these are called as analytics. 90% of the organizations, 90% of industries, when they speak of analytics, they are actually speaking of business intelligence, or they are talking of descriptive and diagnostics. And we had an interesting question to start with about when I build a model, which parameter, how do I use it? That is the realm of predictive and prescriptive. And what we are going to be talking about more is around this space. And if you see, over a period of time, the amount of human input would come down. When we discuss some of the challenges or some of the problems that we have solved in the industry, it will get clearer. Last year, I was part of a prescriptive analytics project, so let me share that experience. How many of you have watched the movie Minority Report? So in the movie Minority Report, I see only 2 hands, so let me go ahead and give a quick context. In the movie Minority Report, what they do is the police department has a way of identifying a crime before it happens. And they catch the criminal either red-handed or before the crime is committed. Now, this is something which is science fiction, or is it? What they use in that movie is clearly science fiction, but what we are using in the industry today is no science fiction. For example, the project that I was part of, it's for a large CPG company working in the supply chain area. We identify, for example, a particular SKU or a stock keeping unit or a product, which could be, say, Lux Pink 100 gram soap, which would go out of stock in one of the depots in Madhya Pradesh 6 weeks from now. So we identify that there is an event that is going to occur. If the product is not at the depot, then when the retailers place an order, it can't be serviced. When the retailers don't have it, it is not there on the shelf. It is not there on the shelf. Consumers come, walk in, they walk out with another brand. Yes.
Can be done through EOQ level also, economic order quantity.
Yes. What I'm going to tell you is the next part, which is once identified that, okay, this is going to happen, going to the next level, identifying what could be the causes why it is going out of stock, identifying who are the people who can get it fixed, sending a note to them saying do ABC to fix this so that you don't go out of stock. So from prescriptive perspective, it is basically giving prescriptions as to what needs to be done to solve a problem which could happen in the future so that you can contain loss. And that's what businesses eventually want. Some of these slides I'll skip faster, but this is from IIA, and what interested me over here is not about the fact that these businesses are investing, but the fact that it is not the enterprises which are of interest to me, it is the mid-market which is of interest to me. Because predictive analytics has been there for a longer time and large players have been using it. Today, due to the power of computing that is available, the mid-market is following up, and that is what is leading to the increased demand. Attitude of enterprises, what is it that organizations think? everyone is clear. There are only very few people who think it is a fad, but otherwise you will see that a whole lot of people have already invested on it and they are expecting that they will get competitive advantage. I'm sure you can't see it, but idea is what are the top 3 things that industries are investing in. And if you see attitude towards big data, now this is another term, we'll discuss about this a bit later, but that is another term which is driving analytics. 36% who already say we have made significant investments and looking forward to gain competitive advantage through this. What are the different types of data that are being used? So this is another organization, IDC. Now if you see, their number 1 priority is cloud, big data and analytics. So what is it that they are saying? They are saying that analytics by itself has been there for a long time. Why is it getting prominence today? It's because you have huge amounts of data and you have the computing power. Someone mentioned Moore's law. You have the huge computing power that is available, and you can actually run these algorithms in complete data sets and not just samples. There is a debate among data scientists which is a better approach, simplistic approach or full data approach. But today's businesses, large businesses have taken a decision. Now that they have computing power, they want to run these analytical algorithms on huge data sets. Now, when they want to do that, the challenge is the processing power on premise. When the servers are sitting in their data centers labs, they have a scaling problem. So we had one of our customers visiting us and telling us that, you know what, we have a huge data center which is filled with these machines, and we wonder how do we sustain this because our computing needs are only increasing. So there is a clear movement to the cloud that is happening. From business terminology perspective, capex versus opex. Instead of spending money on capital expenditure, pay as you use. And that is why organizations are moving to cloud. Cloud-based big data analytics solutions is the current already. Mindtree has a solution, a platform which we call as Decision Moments, and it's built on Azure cloud, where we use the power of Azure to use big data analytics, and we use the power of R and Python to write the algorithms and bring it onto Azure. So the point that I want to make is big data analytics on cloud is the thing. The journey that many of you would be starting, I know it's a 3-day program. It's just the beginning of the journey, because eventually the bucks are. Interestingly, another angle that I wanted to bring is mobile subscriptions are on the rise. So more and more people have smartphones. What does this mean? People have data at their fingertips, and because of the bandwidth increasing, the video content that is there, the consumption of video content is increasing. If you remember Facebook 2 years back versus Facebook today, you will see a lot of videos which are being shared. If you think of WhatsApp when you started using it versus now, the amount of videos have increased. And why are mobile phones of interest? Because in the world of Internet of Things, these are things which we already have without knowing that these are things, and without knowing that the device, my device which is sitting there on the podium, could be interacting with the devices already around here in terms of exchanging information, and we may not even be aware of it. One of my dreams is to be able to watch the data as it is moving around in the air. So smartphones are clearly on the rise, and Asia is the place where it is happening, which leads us to Internet of Things. As per this is slightly dated already because this is 2016 data. We are in mid 2017. Latest estimate is there are 6 billion things and we are not considering the mobile phones or the laptops or desktops. There are things, 6 billion things already generating data, and that data is being streamed, and eventually that data needs to be analyzed, and which is why analytics is relevant. Not very much visible, but then the point that I wanted to make over here is IoT is the big thing from Forrester Tech Radar survey, and they are saying it would take up to 10 years for it to become IoT analytics to become a reality everywhere. And if you see, IoT is already there, people are already using it, but when we say IoT analytics, we are talking of predictive analytics, and we are talking of real-time analytics, not some decisions which have been made in the past, but at real time can decisions be made. We all know of the case where open heart surgery happened and a heart from, say, BGS Global got transported to Chennai and the green corridor was enabled. There was a lot of human intervention. Can this entire process be done by things, by themselves? That's where we are headed. The next few slides, I would be discussing about something which fascinates me called hype cycle. Now, before that, I'm part of Mindtree's Big Data Analytics team, and the Big Data Analytics team is part of the digital team. And digital is the largest contributor to Mindtree's revenue. We contribute around 38% of Mindtree's revenue. So why digital is such a hype in the industry today? I spoke of IoT, I spoke of mobile phones, I spoke of big data analytics, cloud. All this is part of the digital world. And Gartner puts it as the nexus of forces, and the nexus of forces that they talk of is SMAC, Social Mobility Analytics Cloud. And what happens after that is what they talk of in the digital business. I'm going to talk of something called a hype cycle. I have next 6 slides around this. I have been following this from 2010, and this gives me a sense of where the industry is headed in the next 5-10 years, and how we can plan better for the opportunities in the analytics space which we can work on. 2010, when I started looking at this report, my teams were already working in predictive analytics around that time. And if you see, this was, okay, let me take a moment and explain how to read this curve. Initially, there is a technology trigger that happens. For example, current thing you hear is printing, 3D printing. Food particles, food also can be printed. So that's what we hear. It starts off as a technology trigger. Then there is a peak of inflated expectations. There's a lot of hype around this particular topic. Everyone is talking about it. Lots of startups, lot of investment happens, and then it reaches its peak. A lot of people are invested. A lot of people will fail as well, because not everyone will succeed, and that failure dissuades others from investing further. And then there is a trough of disillusionment that industry goes through. The big players, though, they don't stop investing, they continue investing. And the best practices emerge, and the followers start following it, and then there is a slope of enlightenment. The industry as a whole starts adopting something, and then it starts adding value to the bottom line. That is the plateau of productivity. So in 2010, when I was first looking at this, I was already working with a team who was working on predictive analytics, like Lakshmi, who has joined us. And at that time, predictive analytics, we were like, okay, it's there on the slope of enlightenment, and now we are going to see more and more of this kind of work. We come to 2011, predictive analytics moved slightly, but if you see the color of this, it's a white dot which says it takes less than 2 years once it reaches for it to hit mainstream. Around 2011, 2 other interesting things came up. There was something called social analytics. Social media usage was increasing. Internet of Things was just catching steam. 2011. 2012, the term appears over here for the first time. And as you see, it's not a technology trigger, it's almost a hype when it makes an entry itself. Internet of Things is still there. Social analytics has started moving down the hype. In-memory analytics and text analytics started gathering steam, but predictive analytics still did not get off the curve. 2013 predictive analytics is still there. In-memory analytics has moved a little. Gesture control has come in. Content analytics has come in. Big data has moved to the peak. Internet of Things has moved up. Prescriptive analytics makes an entry as an area. 2014, big data starts falling. Predictive analytics has become mainstream. They don't cover it anymore. Internet of Things has reached the peak. Data science as a terminology is used in the industry extensively. I have a blog talking about how data science as a concept has been there for over 50 years. The terminology was used more than 50 years back, but it became, from a business perspective, it became a big hype in 2014. Come 2015, big data goes missing. This is one of the fastest trends which has become mainstream. And I wrote a blog around that time saying why big data is no more a hype and it's a reality already. So machine learning makes an entry in 2015. Machine learning again has been there for ages. However, now is the time when we are talking of machine learning. This is last year's. 2 to 3 months down the line, 2017 hype cycle would come. Maybe if you keep an eye out for it, then you will be able to see that as well. So if you see, big data is gone, data science is not seen anymore, machine learning is still high, and whatever we are talking of analytics, essentially in a way is linked to machine learning. Blockchain makes an entry. A colleague of mine made an interesting remark. I was asking him how blockchain and analytics are related. He said that blockchain to a certain extent will make analytics redundant. We need to be aware of that as well. The problem statement that we are trying to understand, it could be on the verge of becoming redundant because of some other trend which is coming up. So the reason why I shared this is this kind of gives us a window into the world of opportunities that exist in the big data space. And this allows us to see, it's my window to look into the future. I know what are the technologies that I should be focusing on. In my role, I have a team of around 180 members who are working in big data and analytics. In the big data space, we counted 112 tools last count, and the count will be increasing. 112 tools already there. Interestingly, I did a survey of all my projects that we are running, and we found there are around 80 tools already being used and counting.
This is 112 is proprietary included or including
everything, proprietary, third party, open source, everything, all tools put together. I have a slide later coming up to say it is not 112. So
one question: what is difference between machine learning and
AI? Thanks. I'll park that question. I have some slides on AI much later. Machine learning is just one part of AI, but it is the most crucial part as of today. It is the one working cog in the wheel, because of which the wheel will continue to run for more time. Machine learning is the one which is already being used, whereas other areas like vision, like speech, natural language processing, robotics are all trying to catch up, but machine learning is already there. So with that, I would hand it over to Lakshmi. Maybe you need to stand there.
Good afternoon, everybody. So, as Vinayak introduced, I'm Lakshmi Pawar. So, I'm a data scientist in Mindtree. So, to begin with, already Vinayak has mentioned about opportunities. Now we are going to have, wherever there's opportunities, we know that there are challenges as well. So again, these challenges, what we are going to discuss now would be in two types. One, what are those challenges which customers give to us? So what kind of challenges do analytics companies generally receive? I know most of you would have come across few of the challenges which Mindtree has worked for various customers. And also, when we work on those projects, challenges also. So we'll discuss both kind of challenges now. Hello? Fine. So to begin, I will be discussing few of the use cases which we have done for our various customers. This is one of the most successful projects which we have been doing in Mindtree for past 7 years. This is for one of the leading FMCG globally, and they are predominant in India especially. So here the business case given to us was, how does this company sell right SKUs to the right stores at the right time? So we had to sell right products to the right customers. That was the overall high-level business objective which was given to us. So in order to do that, so we had to identify the items. So this was, imagine the outlets which we see, all the Kirana stores which are there across in all the corners of the roads which we see. So at every outlet or in every store, we had to identify which of the SKUs or the stock keeping units which are likely to go out of stock, which of the stores have the potential to sell more SKUs, and which of the stores are already selling the SKUs, but can they sell more? So this question is more of out of stock identification, cross sell and upsell. So this was the business challenge given to us, and you can imagine there are around 1 million plus outlets in India especially. I'm just talking about India, whereas this project we are doing it for 23 countries globally. So in India, if you imagine there are around 1 million plus outlets, there are around 2,000 to 3,000 SKUs. So for every SKU in every outlet, we had to identify this. So what kind of data we had? We had data of the outlets, the entire transaction data. So the data which we had was not that what outlet sells to its customers, which we call as point of sales data. It was not that. But what we had was the secondary sales data, which the wholesalers generally sell to the retailers or these outlets. We had secondary level sales of data, and we had the sales transaction. What did they sell? How much did they sell? So we had a historical sales data of around 2 years. Using that data, and also along with the third-party data like demographic data, which we generally buy from companies like Indicus, we procure data from Indicus. So this data was more about the demographics of the outlet. So what kind of outlet, what is the demographical components there? So how many people live, what is their standard of living, what is their income range? So these data will help us identify what is the nature of the outlet. Do I have potential? See, some outlet like which is in Koramangala can sell premium products, whereas an outlet somewhere in a remote place inside of Mysore Road, they don't sell premium products. We had to identify that to really identify what can be sold where. So this demographic data along with the internal data helped us to identify the SKUs to be sold in right amount to right stores. This recommendation goes live to the salesman. So the salesman we see, he carries things in his motorcycle and he goes. So these recommendations go to his handheld device. So it will tell him that in this store you need to sell this much. There is a red line item which we call as out of stock item which you need to look after. This is how this recommendation which we are doing is going on from past 7 years. Due to the success which we saw in India, it's been globally established in 23 countries and it's an ongoing project for us. So next is on demand forecasting. Again, this is for the
Why can you apply? Why does it not stick?
So why did it was a classification problem. Suppose if I have to do a cross-sell model, if I had to identify in a
Generally, regulation, right? Logistic is applied only for categorical.
exactly. So the how did we arrive at your dependent and independent variables? So what was my target variable? It was it's a 1 and 0. So what is that? In every outlet, I see what I do is I do a outlet segmentation. I see what is that other similar outlets. When I do clustering, I get similar outlets in one cluster. I see that okay, outlet number 1, 3, 5 are already selling this, whereas outlet number 4 is not selling this. So if it's not selling, I tag them as 1. If the others are 0, that would be my dependent and rest would be my independent.
I would just want to add something to this. If you go back to the previous slide, you see logistic regression, and we say we have been using it for 7 years. In 7 years, we have tried using almost all the algorithms which would be remotely useful for this, and we find logistic regression works better than those. So one of the questions which people keep asking is, there are so many algorithms to learn. What would I do? Say learn at least one, say learn few, understand how they work, and 90% of the business problems could be solved using simple algorithms.
Yeah, in the course of time, we have tried Bayesian analysis. We have also improved it using collaborative. Right, we first started with doing collaborative filtering, where we do item to item. We get a index to that, include that in logistic regression. We have done multiple improvements, and right now we are in a phase of trying out Bayesian analysis in the same. So this is another interesting use case on forecasting. I know generally we do forecasting. So this is for the same organization where they at an SKU level they had to identify baseline sales. It is not the actual sales. Generally, what we get is the historical sales. Again, this sales is a function of both baselines and sales due to marketing drivers. We had to separate out the sales which is due to baselines and sales due to the marketing drivers. We had to separate them and then apply our regular forecasting algorithms to generate baseline forecasts. This was the exercise, and there was a huge very good improvement in the forecasting. And right now, it's being used in the organization to generate baseline sales forecasts. Again, in between, I'm cutting many steps because we go with the standard approach, which if we have to arrive at the final step. Yeah, next, the one which we saw previously was for a CPG. Now it's not that we predominantly work for them, but we also have worked for a car rental company. So the car rent, this was for US, where they had the historical data of the customers who used to rent cars when they take cars for rent. This company wanted to identify who are those likely customers whom I can go and target, provide some offers so that they come back to me with more business. They want to identify those customers who are likely to avail their service or rent a car in the next 3 months. Again, the same thing. What we had was the entire customer base. We had to segment in order to identify my most valuable customers in terms of their volume value, and then target them and apply predictive modeling to out of that targeted segment, who are my most valuable customers, whom I can go and offer some campaigns or promotions so that they come back to me again with more business. The next is a CP. Again, this is very predominantly used use case where everybody would want to do, which is called as market mix modeling. So everybody would want to know companies invest too much on promotions, and they are really struggling to find out how much is promotion giving me the ROI. So what is the ROI I'm getting to the promotions? Promotions are in so many forms. We give a lot of, they spend on advertisements, they spend on promotions, buy one get one offer or 5% off. They do so many things to attract, but is it really giving them the ROI? That is what they wanted to know. Again, market mix modeling is a function of 4 P's, which is price, promotion, product, and place. So for every brand, these 4 components, which is price, promotion, distribution, advertisement, and competitor impact. Out of all these factors, which is the most important factor which is driving my sales, which is impacting my sales to grow or decline? We had to identify that. So that we call as market mix modeling approach. We could identify the contribution of your sales increment is this much. If you increase your price by this much, the elasticity of your sales this much. So we compute contributions and elasticities. So this keeps coming to us very often. Everybody are interested to know how much is their promotions giving them back. What is the ROI? Likewise, if you see the similar case,
If you could cover the previous use case,
yeah.
if you could give that example of that beverage where promotion didn't really matter beyond a point.
Exactly. Okay, fine. So more than modeling, sometimes it happens that there are true insights keep coming up. So this was very something we did this for Indian company and they have Complan and Bormita. So this company, there were two teams, both the marketing team on media and the promotions team. Promotions team, the promotion planning team actually believed that they spend so much on promotions, they should get more ROI. Whereas the media, what we saw when we built the model was there was a huge impact from media rather than promotions, because no matter what, whether you give promotions or not, Horlicks and Complan are the brands which the South Indian mothers are definitely going to buy. So there's so much glued to that brand that the media impact was coming up significantly, which the promotion planning team were like surprised. Especially for brands like Horlicks and Complan, it works very well in South and East, whereas North and West they don't sell much. So the media had a very huge impact on this. So promotions, even though if the company stops giving promotions, still the sales will happen. So such kind of insights comes up while we build these models, compute contributions and elasticity.
Say promotions and media. For me, both are same. How do you?
They're not actually same. When I said media, both are in form of spends. One, when I meant promotions, the consumer promotions which I give you
Discounts.
Discounts. So that is like it's like buy one get one free or a 10% extra, or that's a consumer promotion in a form. Whereas the media is the advertisements. You spend on TV also, saying these many GRPs. So we receive GRP data from the media companies. So where did that most of the advertisement, who saw how much in a way to capture that? That is advertisement impact. Yes, about
In the previous case, when you were talking about one of the FMCG example,
right,
that the salesman gets the
recommendation.
So, but there are some non-controllable factors, like for example, a distributor. He has got some problem, like area is vacant.
Correct.
So, and there is a stock out. Does it impact? Or else there are some non-controllable factors like competition. So suddenly they become aggressive. There are no schemes, discounts, left, right, center.
Yes.
So how, like those factors, will it impact?
Definitely does impact.
Is there a scope in your research?
It is there. Definitely it does impact whatever the competitor is doing or however the distribution, yes, that needs to be considered. When I said we are building logistic regression model, those components, in this case, we did not get competitor data, but we had distributor data. What is the volume percentage of distribution? We have two components like numeric distribution and weighted distribution. We include them also while we build the logistic regression. Yes, it does impact. And we incorporate them while we build the model so that its effect is also accounted when we get the recommendations.
Just would want to add a little to that. Many times when we think of an analytics problem, we think of it in terms of a mathematical equation, whereas in reality, the field knowledge plays a major role. Our data scientists go on field visits, watch the salesmen selling, understand what is happening on the ground. That knowledge is what they bring back and apply in the model also. So that, sorry, you had a question.
So, regression.
In general regression model, you cannot capture the latent elements.
Yeah, we use these structural equation modelings most of the time. Yeah, so we do that. But when we have direct linear relationship variables, we use linear regression. So as Vinayak was saying, most of the times things get worked with simple stuff only. But yeah, SEM is also there. We just look at. So this was about market mix modeling. Again, this is from the different domain, which is banking domain. And as we all know, the biggest challenge for banking domain is to identify who are likely to churn, which customer is likely to churn. And simple, we get the transaction history of their existing customers. These are all supervised algorithms, so we know 190 already. So we would have identified customers who have churned earlier. So we tag them as 1 and the rest as 0 and look into what kind of attributes will impact a customer to churn. So that is what we did for this banking company in US. This same customer had customer complaints. Now this is a use case for unstructured data. So all this while what we spoke was most of it was structured data. Now here comes when you have a lot of text data, how are you going to mine? How do you arrive at the negative sentiments, positive sentiments? So we did text mining and arrived at the positive sentiments, negative sentiments. I think we stopped at text mining. We did not proceed further on topic modeling. But so the next is on a European energy company. This company basically sells power or buy. It's not like India. So they sell and buy power. Solar. So solar power. So they wanted to identify, again, it's a segmentation problem. They wanted to identify right customers, the target customers, so that they can go target them and get more business out of them. So we did, and we identified who are those target customers, who are like ones.
Just to add to that, for example, electricity consumption for an organization or which is working on freezing tomatoes versus another one is trying to meat products. The requirements of where the segmentation helps in identifying who has a better requirement. Of solar is that consumers are not just consumers, sometimes they sell as well. So organization like this wanted to know at what time will the customer really buy us, when will he sell. The pricing becomes important. Based on the demand, they can play around with the pricing.
I think they are covered in the so we could identify this. Again, we did forecasting also for them. Next is again another area which is predominantly coming up is predictive maintenance. So where most everywhere these applications, system applications, we have a downtime. It's not another area where we are getting a lot of analytics work. Where they maintain applications, they would want to analyze why is this downtime happening. They want to forecast when does the system fail. So what's the downtime? When is it likely to go? When is it slow down? So the predictive maintenance is another area in the same context. This is for a German tableware manufacturer where they manufacture coffee vending machines. So they wanted to, in order to not disrupt the customer services, they wanted to kind of be proactive and identify when is the machine likely to go or halt or stop its service. So again, we had similar data sets to identify how the usage of that particular machines, and based on that, we kind of identified which machines have a high probability of to go to fail.
Just would want to add something more onto it. What we found was the time of the maintenance engineer is very costly, and they would want to plan his time well. For example, if he is visiting a location and if there is a possibility of him getting a complaint in that same location within a week's time, rather than act after the event happens, if he were to just go there, fix the problem before it occurs, that would improve customer satisfaction. There are some intangible benefits that come out of this kind of
So you mean to say that it is real-time data, not historical?
No, this was historical. So
No, because when you're talking of text mining there,
right.
Are you not, at any point of time, have you used data in real time?
No, for this context, we have not.
This context, no.
We have not.
In this context, no. Answer to your point is, in real time, have we used?
Yes.
Not yet. We have not yet reached there because capturing sentiments is an area which has not yet been completely solved. With historical data, we do it. Still, engineers look at what could be the wrong interpretation of the model. In real time, if we implement it, it has its own challenges. Like recently, there was this case where a person tweeted that, thank you for ensuring that I reach the city A and my luggage reach city B. And then he got an immediate feedback saying, thank you for your feedback. Yeah. Because the system didn't understand sarcasm. And this is why real time will become a challenge.
So is it the US bank opportunity is the same thing, cross-sell, upsell. But the very interesting one which we are currently working on is on this European airline. So they have huge amounts of data. They wanted to identify from an origin to destination what should be the price. This is an ongoing project which we have just begun, and it's very complex, and we are using generalized additive models to come up with the fare for one fare or origin to destination, what should be the price. When should the airline person or the person who decides on the prices stop taking bookings from one class and open the next class for booking. So that price, that is called as buy-down adjusted fare. Once it turns negative, then he is going to open the next booking class to make bookings. So this is an ongoing project. So in all these projects, few of them have our small data sets which we are able to work in R or Python most of the times. But there are other projects where we are working using big data Hadoop stack. So for this example, this is one where we are using Microsoft R to do parallel processing and to arrive at the origin destination. It's still going on. So the first one which we spoke,
why you had chosen Microsoft R?
Yeah, this was mostly from the customer. The customer wanted to use MRS rather than Azure or Amazon. So it was a requirement from the customer. I'm right. Yes, the requirement.
So if you would repeat the question, why MRS? Was that the question?
Yes.
Or R versus MRS?
Yes. Already R is there. So
okay. So from a historical perspective, R has been there. There's a company which is called Revolution R, which took R and scaled it. Microsoft acquired Revolution R and they're using MRS for scaling. If you remember earlier we were speaking of, traditionally we were working with sample data sets, but now we are working with the entire data set. So here we are talking of a big data problem, huge amount of data. Just to give you a sense of this data, we are talking of say around 5 TB of which gets processed. The incoming data could be 2 GB, but when we process it, it is 5 TB of data that is getting processed. And for that, we need power. So what is happening in this case is, if I remember it correctly, we are using a system with 1 TB RAM. We are using in this case, it is on-premise. They have not yet moved into the cloud. The development system is 1 TB RAM. So you can imagine when it goes to prod, how much RAM would be required. So that is a big data problem.
Yeah, that is why the processing time is, for example, the one which we did for an online grocery store, I think I can take the name Big Basket. So we are the Big Basket wanted to know the recommendation, and they wanted to say for their customers, they wanted to say that, why don't you try this like what we see in Amazon. So Amazon says customers like you have already bought this. Similar way, even Big Basket also wanted to do that for its customers. So Big Basket has around 9 lakh customers with them, and they have around 35,000 SKUs. So for every SKU, for every customer, you can imagine they had 5 terabytes of data, and the processing time using the Azure. They had selected Azure, Amazon Web Services, AWS. So using Redshift and the Hadoop technology stack, we were able to give recommendations. Say item to item. In fact, we used collaborative filtering here using cosine distance. I think cosine in that, and for item to item, we were able to give recommendations for every customer, for 9 lakh customers in 5 minutes. That was the processing. So Big Basket was doing it in-house with smaller samples of data. They wanted to scale up. They wanted scalability, and the level of achievement we used with using these technology stack was we were able to give recommendations in 5 minutes, so item to item. So for all the customers. So that is what customers are looking now. They are looking at very sooner decisions.
So scale wise, yeah, please.
So you're saying within 5 minutes of the customer making a purchase of
No.
A.
The recommendation.
No. So that's my question. I want to understand 5 minutes is from where, what time to what time? I mean, so is it from the moment I make a purchase on Big Basket, within 5 minutes of that you are able to tell me what else I can buy or what else other people like me have bought?
It's the other one. It's not after you buy. I look at the historical sales data. So what we are talking about is the processing time. So if you, as I said, 5 terabytes of data, 35,000 SKUs, 9 lakh customers. If I have to do a recommendation saying that Lakshmi is going to buy this or Vinayak is going to buy this, algorithms behind which is, as I said, we have used collaborative filtering there. If you have to do that, and imagine the computation, again, every customer, every item has to be browsed through all other items. Internally, the data computation will be humongous. So the output, we end of the day, we want to see the recommendations. That we used to get in 5 minutes.
To add to that, please note it is not real time.
So if I select the item, add it to my cart.
Yes.
For the next available items, I can choose to play product. Like if I buy a badminton racket.
Yes.
Along with that, badminton shoes, socks,
yes,
shuttlecock.
Yes.
Everything will come within 5 minutes.
No.
So that is why, let me complete. There are two things over here. What is happening real time as a user when you are doing it is already cooked, pre-computed information. It is not happening at real time. But to be able to create that is what she is talking about. The 5 minutes is the background processing time, not when you are clicking there. No, it's not real time. So these things run in batch. Real time would require much more power, and not everyone is capable of doing it. Because power basically means this. Are you interested in investing that much for real time? That's where the problem is. What I wanted to add to her point was, from an infrastructure perspective, we are speaking of 15 nodes on Amazon Web Services AWS, each node having 32 cores and 244 GB RAM. So you can imagine, with all this power, 5 minutes if it is able to solve, you can imagine if it is taking 5 minutes with this power, what is the problem we are talking about? And that is the challenge. That is the scale which is the challenge. Maybe you could go to HUL.
Yeah.
Or same thing, when we apply low power software and huge data, system will get hanged.
Exactly.
That's the major problem.
That's the problem with our. If R has more than 3 lakh rows of customer data, R is not able to do its processing.
Handle the first data points.
If I'm a first time customer, then this
This
recommendation.
order.
So in the interest of time, I have 5 more minutes to go. We'll take questions maybe once I complete it. Am I audible? Sorry, I'll take your question in 5 minutes or maybe offline as well. So these are some of the challenges that we spoke. Whatever we spoke was the first part of the challenge. But here if you see, these are all the different challenges that we have in order to run a project. This brings more complexity than just the data complexity. And this requires a lot of people skills. Data quality problems, where there are, there will be there. So this is something which is the nightmare of any data scientist. Popular statistics say data scientists spend up to 80% of the time cleaning data. Infrastructure challenges, we spoke of how movement to cloud is happening. And from an operational and production challenges perspective, how do you productionize a model and how do you ensure that that model is working? How often do you tune it? These are also some of the challenges. From a technical perspective, this is what it used to be when we started the journey 50 years back. KDD would suffice. But then analytics became a box in a logical BI architecture. And then with the big data space, Spark is being used to solve the problem. And this is where the analytics is happening. As you see, as the complexity increases, the place that your analytics is playing is limited and it is dependent on a whole lot of external factors. And if you see, this is Amazon Stack, the number of tools that I was talking of earlier. And this is just a glimpse of some of the tools that we are using in our projects. And this is what industry is using. This is just one piece of the whole puzzle. So come back to the 4 point that I had started the discussion with. Neuroscience. How does a neuron work? Understanding how a neuron works, how neurons communicate with each other, and in a loose sense is what is being used in neural networks. I said loose sense because even today, scientists who are working on memory do not know where memory is stored. Human memory, they do not know where it is stored. And you could read up further on this. And whatever we are building neural networks, it is based on the understanding, rudimentary understanding that we have managed to gather over last 50 years. Quantum physics, we gave the example where 5 minutes with that much raw power, the problems we are still taking 5 minutes to solve. Quantum physics is what everyone is looking at. You mentioned about Moore's law and how quantum is going to be important. Finally, we are talking of machine learning. There is this concept of adversarial machine learning, wherein you are trying to have two models compete against each other. One model throws a problem, the other model solves a problem. And to understand how models will interact, that's the easier part. But then, how are humans going to interact? There is one emerging field in data science called security data science, which is basically saying on this side of the world, if the internet and the organizations are using a whole lot of technology to do what they want to do, the amount of cyber attacks are also increasing. And on the other side also are humans. So a computer can be as good as it can be, but a human can always fool it. So understanding how humans think is also going to be very, very important, whether to create an artificial intelligence algorithm or even to say, protect ourselves. And finally, with the amount of tools that I mentioned, your own learning style becomes important. Your understanding of how you are learning things becomes important. I was talking to a cousin, I had a question on should she choose accounting versus finance for her specialization in her graduation. I gave her an answer, and finally when she persisted, I said, look, it doesn't really matter. 5 years from now, by the time you hit the industry, jobs as you know today will cease to exist. And one thing which will definitely help you is your understanding of how you are able to learn, because the life cycle of a particular tool or a particular technology is coming down, and our ability to learn things is what is going to define how successful we are going to be. With this, I come to the conclusion. Do you have any? Would you give me 2 more minutes? I just have. We said we'll discuss about AI a bit. So this I picked up from Amazon Web Services website. They are saying from AI perspective, the next level for them is to understand how people see, to understand how people talk, and hear what they are talking and react to. Now, you see, this is a simplistic way of looking at AI, and we said machine learning is one part of AI. So if you see, machine learning is here, but this space is still emerging, it is still evolving. So machine learning will become smaller and smaller as AI grows, but it will still continue to be the heart of AI as we see it today. That means there are that many opportunities. There are hundreds of companies, startups, which are in the space of AI, and that basically means the world ahead of us is going to be interesting and challenging. If I were to leave you with the 3 things that you would want to take away with you, one is be aware of what is coming, be able to see what is going to happen in the next 5 years. Keep your saw sharp, which is ensure that you are learnable, you continue to be learnable, because in the industry there are lots of layoffs happening today. It's because people are losing learnability. So some of the problem statements that we mentioned earlier are not solved really by data scientists who have gray hair. It is solved by college graduates who have less than 2 years of experience. And our data scientists, senior data scientists, Lakshmi who vouch for it, are learning from them. That is the space we are in. So learning, our ability to learn newer things becomes extremely important. And finally, to conclude, while AI is everything, human brain has got ways of doing things which we still haven't understood. So the more and more we are able to understand ourselves as to what we say, why we act in a particular fashion, self-analysis is what is going to become very important in the years to come. That's where the human psychology comes. Thank you very much. Thanks for your patience. And if there are any questions, we'll take it offline. Thanks. Yes. You would have realized by now, she's the real person.
Ma'am, please take it from here.
Yes.
Same.
I need to answer that.
Yes.
Okay, you can tell me your question.
For example, I want to forecast sales for the next 5 years.
Right.
I'm using either time series regression or exponential smoothing. What is the optimal data requirement for this?
Ideally, it depends from domain to domain. For example, if I have to take FMCG.
Let's take the grocery.
Yeah, let's take this FMCG. So here FMCG, if we are going to do seasonal forecasting, if the SKUs, definitely the few SKUs like Pond's cold cream are purely seasonal. For that, we would require 3 years of historical sales data. Maybe at monthly or weekly would be more noisy. What we generally ask is for monthly. So monthly sales data of 3 years if there is seasonality. If there is no seasonality, 12 to 18 months, actually 18 months of data is required to understand the trend. So we have to capture trend component in order to forecast future when there's no seasonality. If seasonality, trend, both are there, we would require 3 years of historical data.
You are saying for most practical purposes, 3 years of data or more is good enough.
It's only for difference.
Yeah, well, again, if it's something like a trading or stock market, so it depends from domain to domain. So not every.
That's where I was.
Yeah, it depends from domain to domain. The example I gave was for the.
So you had a question when we started off.
Yeah, means there's lots of algorithm actually in R and many other tools, but there are many parameters also we are passing. So what should be the best value of each parameter? Do you have any research or something?
What should be the best value
of each parameter for particular algorithm, like logistic algorithm?
Yeah, we basically look at, first thing we look at the p-values.
P and Gini.
Yeah, Gini coefficient, we look at that. We look for the significance first. We look for the signs, the positive, negative signs, the coefficients. Okay. So the negatives, the signs mean a mean in terms of interpretation. We have to look at the signs. We look at for the statistical significance signs, then the ROC curves.
Okay. Yeah. One more question. How do you manipulate the data? Sir said data manipulation is also one of the complicated.
Data manipulation.
For example, for regulation, it works only for parameters.
Yes.
So if there is any violation, whatever the results you arrive at, explain.
The results might not be explained in the sense the variable is not significant.
No. For example,
so I request you to continue this discussion offline, please.
Maybe I'll talk to you.
Yes.
Friends, we are having a lot of intellectual sessions. I think right now we first need to thank these two professionals for taking their time out on a working day. So I have to place this on record. When we contacted first Mr. Vinayak Pai, he said, slot me on Friday session anytime. So we have spoken around 4 times telling that's very kind of him to say anytime. You know, that was, thank you so much, sir, for taking your time. Ma'am, thank you so much for being here. So I'll request our Center Head, Dr. V. Vasu, to kindly hand over token of our appreciation to Mr. Vinayak Pai. And Ms. Lakshmi Babu. We'll now break for lunch, and just before we do that, we'll have a quick group photo. So I'll request all the participants to stand up, leave the laptops as they are. We'll have 3 rows right here by rearranging those chairs. All our student volunteers will take care of that. Don't worry about your belongings. We'll just take the group photo, leave. By the time we get back, it will all be arranged back in place. Only the chairs must be left vacant where you're seated, because we use those chairs for the photograph. Thank you. Just
Can you have you
Excuse me.
Whatever I spoke, most of it I logged.
What's the block called? You mentioned part of my LinkedIn. Okay. I can say that I am not qualified.
One line we can start.
It was great that my student presented in front of me.
That's very special to us. I can understand.
No, when I entered, I recognized her. So, but I waited for her to recognize me because it's more than a check. The minute you gave the same simplicity, I can't forget it. But I was just recording all the time that I entered.
Parents and teachers need to do that.
Especially for square.
And one side we can stand there.
Yes. I registered for
Yeah, one chair is still left. Yeah. So one of you please. Among you should tell us how we have to take. Student volunteers. Can you line this, sir? Rahul. One can stand here also. Come with the height. Thank you all. We'll now proceed to second floor for lunch.
Yes, you are right.
I'll be sharing it.
Sure, thank you. Okay, you are so well diversified. And I was trying something very basic. I because I teach Excel much more than with subject. Yes, yes.
Across the management tries to make them to tap. They will come back to the project that I
Right. It's so user friendly. Thank you so much. I have passion for it. I have been learning Excel from last 14 years and teaching Excel from 6 years. You're right. I agree.
ID card, debit card, credit card, all that is okay, ma'am. We trust. So you feel that we have to carry, we will carry, not that we want to. I'm not participating. Okay.
you get visualization and the Java code.
See, just that. Lunch के लिए second floor, please.
Take your data, replace it with that. Show it to customer. Okay.
D3JS. Okay. Thank you. Yes.
Going back. Going back.
Even Excel, beyond the basics.
VBA.
नहीं सर मैं बोल के लॉक करवा के आ गई बस
ಲಾಕ್ ಮಾಡ್ಬಿಡು. ಲಾಕ್ ಮಾಡು.
ಹಿರಿಯಣ್ಣ ಫೋನ್ ಮಾಡ್ತಾ ಇದ್ರು. ಮಾಡ್ತಾ ಇದೆಯಲ್ಲ ಯಾರು ಇಲ್ಲ ಅಂತ್ಯಾ? ಗುರು ಕೀ ಇದೆ. ಗುರು ಲಾಕ್ ಮಾಡು ಗುರು. ಕೀ ಇದೆ. ಇರು. ಇಲ್ಲ ಸೆಕ್ಯೂರಿಟಿ. ಸರಿ ಲಾಕ್ ಮಾಡ್ಬಿಟ್ಟು ಬಾ ಹಂಗೆ ಇರಲಿ ಜಾಸ್ತಿ ಸೆಲ್ ಖಾಲಿ ಆಗೋಗಿದೆ ಇನ್ನು ಚಾರ್ಜಿಗೆ ಹಾಕ್ಬೇಕು. ಇಲ್ಲ ಹಿಂಗ ಲಾಕ್ ಮಾಡ್ಬಿಟ್ಟು ಹಿಂಗ ಬಾ. ಆ ಕಡೆ ಇದ್ದಾನೆ. ಹಾ.
Thank you, sir. Not much.
Not blue, black. Then take this. Take the AC report, switch on, no?
It's on.
Can I slightly move this? Too much.
So I understand, the accents very well. नाम सुना हुआ I got admission into PhD. ऐसा सीवन भी किया नाम सुना हुआ थोड़ा सा आप बोलते थे बड़े शहर से मैं 95 बैच का मैं तो हॉस्टल में था कुछ 25 साल हो
Anyone happens to have HDMI connector over here.
अच्छा अच्छा ऊपर का देख प्रोग्राम मैनेजर change will I can't think. Which batch you running the year are अरे बहुत सीनियर बहुत सीनियर नहीं कुछ नहीं एक दूसरा स्टाफ करके आते थे हॉस्टल सीनियर लग नहीं रहे मेरे खुद के दोस्त चेंज हो गई ऐसी पता नहीं चल रहा हाँ 99 इसके हिसाब से 8 साल
Good afternoon, everyone. Welcome to the fourth lunch session. I would like to invite Rahul to read the profile to introduce Rajat Sarkar sir.
Good afternoon, everyone. I'm introducing Rajat Sarkar profile. MS in Stats, works with data consulting service as business analyst for 3 years. Then worked with Deal for Loan for a year as a data analyst in R and Python. Presently working with iNurture Education Solution as senior faculty in business analyst.
So I would like to invite you to take the session.
Good afternoon, everyone. We are not having the HDMI cable. It's getting very soon. So meantime, I want you to open R Studio. R Studio.
As in this.
You have how many hours? Zero.
Okay. Are you ready with R now? Okay. Is it visible? Is it okay now? Better? Okay. Okay, next. Now, before we start with hypothesis in this next session, we'll first know how to pull the data inside R, and we'll learn how to see the data and how data summary is looked at, and the basic aspect of it. So, with which you can go ahead, right? So, to start with, this is called as R console. Do you see that written there? This is where your program gets executed. Just above that, that's where you can type your code and you can save it. But if you execute this code in console, run it, it's gone. Right side, you have your graphics will come there. Suppose you want to plot some data, you'll have your plots there, and above it, whatever code that you're executing, it will also be there. Okay, now first thing I will start with is reading a data. So the first command that you write, follow the step with me. Give it a name called data. So whichever file that I'm pulling will be saved as data. What happened? Okay, now you must be having only console. Is that it?
Yes.
Just try to tab. I mean, there is a space. See?
We can't see this layer.
Which one? Can you switch off these lights?
This light is
If you switch it off, that the live stream is.
you have to.
If you want to switch it off, no one is.
Hello. Leg is still there or it's gone? Ma'am, is it okay now? Okay. Is it okay now?
There is some glare there.
That's projector's glare.
You can see that side, right? Yeah. Ma'am, that is visible to you? That is visible to you, ma'am?
Not that clearly.
You can manage it, right? Okay. So, data, right? Now I want to read the data set. So first thing you're going to write, and that data would be a CSV file. So what you will do is go to that file location called day1 and enter the Tableau folder. Okay.
Everyone is getting these 4 windows, no minimum. These 4 windows are there are 4 windows, 1, 2, 3, 4.
But here we have it.
So those who have 3 windows have to open R script from 5. Go to 5. Go to 5 and there is R script and then select new. So you will get a blank R script.
Still didn't come, I think, for few. Yeah. Yeah.
No, besides, you have to open the file.
Sir, can we magnify this projector, sir? Can we do that?
You cannot magnify. What you do is you magnify the R script, suppress the other sections and enlarge the.
I mean, if that is possible, I don't think so, sir.
Yes, See, you might be looking at these 4 sections now currently. This will be blank right now. This tells you how many variables are there on which you are working. Since he has already worked here, that's why there are some variables. Okay. And again, description of whatever sir was trying to do. This is whatever over here, the output will come over here. Okay. So right now you should be able to get these 4 sections. And then whatever sir is trying to demonstrate over here, the first task would be to get in the data on which you want to work. This is what he's trying to demonstrate.
Now I have written read.csv. Have you written that?
Yes.
Now, data equals to read.csv. And the reason why I wrote data, because the file that I am bringing in, I'll store it with the name called data. Okay, now you can go to the link of day 1. Wherever you have saved day 1, like I have saved it in desktop, go there and go to data for Tableau. I'd like to bring this iris file. You see that iris?
Yeah.
I'd like to bring that. So what I'll do is I'll take the link, I'll copy the link from here. Okay? Now you put quotation and paste it.
How do we copy that?
The link part?
Yes.
Sir? Now go to that location.
Yes.
Day 1,
Yes.
Tableau data.
Yes, yes.
Okay, iris data.
Yes.
Go above and copy the link. Okay, now another what you have to do.
Achha, ye copy hai. How will the system know file is?
That I'll do. Sir, you'll have to write iris. Now another thing that you have to do is put double slash. You see, user, and then you have 1/, put double slash over there. All the ones.
Okay.
All the ones. You see, those are over here. You see, all these are single slash for you. You see that? You'll have single. Put double slash over there.
Everywhere.
Everywhere.
For everything.
For everywhere. How many places you have single slash? Put double slash in all the ones.
Sir, just take a pause and repeat.
I'll do that.
Yeah. You will repeat.
Have you written it? The file name is iris.csv. Are you done, sir?
Yeah.
Now you can, put the cursor over there itself in that line anywhere. Just press Control Enter. If you throw error message, or it's okay. What kind of message did you get? Everything is perfect. Nothing. I mean, error message should not pop up. Okay. Then your file has been read. Yeah, control. Put the cursor in that line anywhere. Control Enter. Did anyone get error message? You get a question?
You did double slash. Put double slash everywhere.
No, you have to change the.
Yes. Yes. The way it is there, the forward slashes are there. Just reverse them to backwards. The way it is there, if there are two, then you make capital backwards.
But when I enter, it comes in the next line.
What?
Everywhere it is one of the.
If it is one, then keep it one only. If it is two, then keep it one.
Have graphics. So I think your reading volume. We'll check it out. Okay.
So,
Could you please copy that program and
because
put in a Word document?
let's see. I mean, that's a good idea.
अच्छा अच्छा okay so that's
Is that okay now? Just below that, write hit command. You will write hit data and then again Control Enter. Do you have any problem?
I'm not
Stopping at data for
Copy the path properly. So we have copy the path properly. As a when you copy part, copy the part, right? Just put double quotation. Not double quotation, I'm just double slash. Yes, slash first. If you're putting it to this way, then single slash is enough. No, nothing. I haven't put it.
There are two ways to do it. Either you can use double forward slashes or single backward slashes, whatever suits you. You can use that also. You can use that also. But since we are learning R programming, so our motive should be to know the codes for doing all this. There is one data import wizard.
I think maybe with the way you're clicking it, probably it is able to that.
Yeah. You are free to find out your own way to get the data inside. Yes. There is one import data set wizard also. You can try to use that also.
The file name has to be put, right?
Is this better now? Readable?
So did you check head? Did it come? Did you get the output? Everyone? Okay. I see. A lot of people are struggling in following this file. Okay. So learn another way, and I find it really convenient. I use only this method. So I'll put again data. Type data. What you do is read CSV, and inside the bracket you will give file.choose. Try this command.
Here we can directly put that.
No, Windows will pop up, will navigate and call the file. Okay. Have you written this? Control enter. See, our window has popped up. Has it? Has it or has it not? See, I got this window. So you navigate and call that file again. Just file.choose. See, it has come. It has come. Just it has come. So that's the reason why it's not coming up. The window has already popped up. Did everyone get it? But I find it most convenient is this, rather than putting those links. Shall we go ahead? Okay. So to check first few observations, I have a command called head, and inside head you give data. You have already typed it. So if you want to check it again, check it. Then just like head, you can put tail. Now, what did you realize that? After you pressed head data, what did you get? It will give you first 5 observation. First 5 observation. Now, in case you are not satisfied, you want any such observation to be saved, then what you do is just beside data, beside data, you write in. Yeah. Now, since I have enlarged it, I'm not able to see, but you'll get 10 observation. First 10 observation you can see. Now, similarly, if you put tail, you will see last 5 observation of the data. Ma'am, are you able to do it, ma'am? What happened, ma'am?
I said file not shows, but I don't get that window there.
It's probably hiding there, ma'am. Just
Let this pop up. Then select this and select.
Now next, if you want to check dimension, you put DIN and then your data. Control enter. Okay. This will tell you the dimension that it has 150 observation and 5 columns.
This is why we can choose that whatever we are just trying to demonstrate that how the data has to be
This is not dot, this is com. Okay, try with dimension command. This will give you dimension, the length and breadth of the data sets that you have. Okay. The next is to check summary. You already have found in Tableau what summary tells you. You'll find similar information again. The kind of information that you get is mean, median, minimum, max. The command is summary. Did you all get it? Ma'am, did you get it, summary? Okay, now next is you can check the structure. The structure is, it will tell you what kind of data types you have in the data sets.
Yeah. What mean media you got? I mean, we are getting some other number which says results 416, so that's summary data.
Now, after data one, just take my command. Did I do anything like this?
No, it's only data.
It's only data. Yeah, close it. Okay. Okay, are you with me, ma'am? Okay. Now, if I have to refer to any column, can you give me any column? Looking at the data set, tell me any column. Petal length. Okay, I'll bring the petal length. So what you do is type data, type just data, and put a dollar sign. See what pops up is all the ones. Now petal length, select petal length and press the button tab. It will automatically select it. Okay. Could you do that?
Petal length and press tab. Enter.
Okay. I mean to select its tab. There are you selected it, right? To select it is the control enter. Don't just press enter. Control enter. Okay. Now. No, I mean select anything. It just for an example. Okay. So please get acquainted with the command called dollar. Okay. The moment you put dollar, everything will pop up. Now, what if I have to select multiple columns? Anyone has problem, please? Could you select a column or not? Okay. Now, if I have to select multiple columns, I've selected just one column, right? I've populated the data. Now, if I have to select multiple columns, I'll put data. One is simple length, another suppose if I want to take petal length, PETAL petal. Now I'll just explain you what I did. After writing the command, execute it. Let me know if you are done, then I'll start explaining.
Is it data, comma C or?
Absolutely, ma'am. You are right. After data, you put a bracket, then comma.
Yeah.
Then you write C, then open bracket, then inside quotation, whatever, I mean, how many files, I mean, column names you want to have it to put it there, separated by comma.
So case is
Your column names is case. It has to come accurate.
Error.
You got error? Check if the name of the thing is small. Check the name, okay, if you have put it properly. Check the links. Has everyone got the output? Now, if whenever I have to select multiple columns, what I do is inside the bracket, what will be the first thing is my row. The comma that you see on the left side of the comma is the row that I select. On the right side of the comma is the column that I select. Okay. Here I was supposed to select the column. That's why I have used right side. Now, if I have to go for only one column, I could have just simply put simple length. But since I have to take multiple columns, that is, I've selected two columns, I have to put C and inside bracket, I have to put it in quotation. So if you want to select only one, then you just put in quotation and just put the name of the column. So now try out with rows. Right? If you put one here, see what happens. Just put one before comma, put one and press enter. If I control enter. Did you get that? This is my first observation actually.
What command you use?
I have not used any command. Just before C, I have used one, meaning that I want first row. First row. You didn't get that? Sequence spelling wrong, man, sir. Sequence spelling wrong. Sir, I will never get angry with you, honestly. You just have to type the command properly. What I've done is 1:10. You see that? So what does your intuition say that what can you get the output as? 1 to 10 is what? Number of observations. Simple length, okay. Are you getting it? Ma'am, just yes or giving it up? Okay.
We are happy that we got.
So now refer to the rows of the data sets. So similarly, you type this command, data. What I've done is I've taken rows 1 to 10 and I've left blank after comma. So R knows that if it is blank after comma means I have to select, I have to go with the entire columns.
Data one after that?
1:10.
1:10, comma.
Yeah, 1:10, comma.
And if you want to define the column range, then 1:10 comma or column numbers.
Put as many columns you want, but if you want multiple columns, make sure you put C, the way I've done.
1:10 is for first 10 rows.
First 10 rows.
The box bracket.
Now, what if you have missing values in your data? Okay. Now, this data set doesn't have any missing values. Okay. So how you check it? Is.NA. Okay. What do you get? All true and false if you see. You will never find one true, you will find all false. Meaning this data set doesn't have any missing values. But you cannot scroll and check these false, right? That sounds really stupid. So what I'll do is I'll just put sum before it. SUM sum, then I'll put the entire thing in bracket. Yeah. So what will happen is it says with 0. So in case is.NA found one true here, some would have given that. But since there are none true, so you have 0 as an answer. Okay? Correct. Any. Null value should be like any. It is depicted as any. What's the question?
There is nothing missing. How do you identify the column number given number?
That there is a way of doing it. Since I don't have one missing value, I won't be able to show you. But as an event I come across, I'll let you know. Now, in this file, we have a column which is categorical. Can you tell me what is the name of that column? Just identify. If you want to do head and check it. Species. Correct. That's a categorical term. Just check it. So now, type this command called table. This is for frequency. Now see the output. The last column that you have is for species. Now it has three types of fishes. That is Setosa, versicolor, and virginica. And down there you see 50, 50, 50, meaning there are 50 50 Setosa, versicolor, and virginica. Are you getting it?
But those are variable names.
These are not variables. These are values of the variable species. See, dollar I've selected species. Now inside species you have these three values. These are Setosa, versicolor, and virginica. And I've got the frequency 50, 50, and 50. What if I now want to
This is just a count of the
frequency
variables that you
count?
have in the file.
Again, variables these are values.
Values of the variable. Values of the
variable species. Now what I want to do is I want to have only Setosa I want. From the entire data sets, I want to have only Setosa. So let's do it. Type is command. Control enter. You'll find only Setosas. Check. You'll only find Setosas. And did you understand the logic behind this? I've selected only the rows Setosa, and I left it column. I mean, select all the ones, all the columns. Did you get this output there? No, you didn't. So, yeah. Tables. Have a look at it. If I put table over there. Okay, I mean, this would be enough for you to go with data. I mean, you can pull out data and you can get this information to start with any kind of hypothesis testing or any kind of analysis you want to start with. I thought of doing Python also, just to go with the basic, but in the interest of time, I'll leave it here. We'll continue with Python tomorrow. Yes.
Of course, this would have gone to another level. Large data. Complicated data.
Am I audible? Am I audible? Yes. So, do we need a break right now? Make it 5 minutes only, right? Then we won't have break till 5 p.m. Right? Then we will complete this session and just small break, do break, something like that. Okay, we'll have break after 30 minutes. The tea guy had come, but he will be coming back in another 30 minutes. So let us start. Okay, this session is for hypothesis testing using R. Can anyone tell over here that what do they understand by hypothesis testing?
We have to mix null hypothesis is wrong. Alternative
Null hypothesis and alternative hypothesis. Okay.
Significance testing.
Significance testing. Okay. And
Whether something is right or whether something is a certain value or not.
Whatever the assumptions we arrived at, can it be extrapolated to the population?
whatever assumptions we have on a sample, can it be extrapolated to the entire?
We are trying to do or disprove based on our assumption, our continuous data.
We are trying to prove or disprove based upon our assumptions. Okay, I'll combine whatever the group has said. One thing is for sure, hypothesis testing is done for sample studies. Now, since this is the age of big data, where we do population studies also, in those scenarios, we will not do any hypothesis testing because there is no hypothesis to test. When we have the whole population data, then we know each and everything. Why will we have any hypothesis? Why will we test anything when we have all the data available with us? Simply count or get the real value, no need to test upon that, right? So hypothesis testing is essentially related with sample study. So the question is, should we do sample study or population study?
But there is a cost to that, right? At time also.
Population study has cost and time. I will give you two examples because there are scenarios where you cannot do population study.
Yeah, it's just not available or not possible.
Product testing.
Product testing. Suppose in testing the product gets destroyed, then how will you do population study, right? You will have to pick the samples. Say you are producing firecrackers, then you will have to pick the sample of firecrackers of the produce, test whether they are burning properly or not. If you will test on all the firecrackers for population study, what will you say, right? So even if we have a lot of big data, your blood test will always be a sample test, right? Yeah. The day the blood test will become population test, there won't be any population. So there is significance and importance of sample study as well as population study for places where we are generating data very easily. Say visitors on our website. So that is a data which is getting recorded automatically. So we just need to have a server which will record the data, and then we can do various kind of analysis on that using big data techniques. But there are places where we can totally not do population study, right? That doesn't make sense over there. So now the question is, since this session is related to sample study only, the question is sample study safe? Because as said, that we will be extrapolating whatever our sample is telling to a population.
We need to select the correct sample.
Correct sample.
Correct sample.
We will explore this further. The thing is that our study should not be biased. Means our sample should not be biased. Number one. And second thing is we must be careful in generalization. Like my thesis study was on Gujarat. Okay. Even if I am telling that I have studied biases of Indian investors, I will have to specify that this study has been conducted in Gujarat with such a sample which does not include this kind of population, say tribal population of Gujarat. Right? Now the generalization of this study will make sense. That it has to be generalized in the boundaries of Gujarat only, and that too not on tribal population. Okay, so generalization and bias. If say sometimes we only pick biases. Like for a faculty to do some research using the students and faculties available in this building will be easier, right? Out of that data, if I'm telling that I have studied academicians of Bangalore, that will be wrong. I have studied with only a single university or a college, it may be, right? So, how much we want to generalize? What is our sample size? So these are the two parameters, bias and generalization. So the question is, how can we use sample in a scientific manner to decide something related to population? This is the question. Okay. Now, we will go through something which will give us an overview that how does that happen. Actually, for this session, this was not required, was not expected. But since our spread of the group is very much, right, there are individuals who are doing this first time, right? That's why I'm explaining it. So those who are already well versed with this topic can help their friends. So see, this is a very good example. This is population distribution. This is how the actual population is. Okay, you can see that population 1 is different than population 2 and is different than population 3. The actual distribution is totally different, right? Now what someone did is took a sample of 2 and calculated its mean, right? From the whole population, took a sample of 2, calculated its mean, and then took many samples, say 1,000 samples, but of size 2 only. And then he started plotting those means. So for this kind of population, he got this kind of plot of means of sample size 2. Okay. This is called as sampling distribution of X bar. X bar means mean, average. Sampling distribution will be what? Taking n number of samples with size 2 in this case, and then plotting whatever mean we got. Say we are plotting income. Even if we are plotting income of Jainagar area, there will be some persons who are like daily wage earners, and if you meet 2 of those persons randomly, the mean will be very low. And randomly, if I meet 2 persons who are in industry, so the mean will be very high. Somehow the plot became like this, sometimes very low, sometimes high, right? Then for this kind of distribution, the plot was like this. For this kind of distribution, the plot was like this. When we took sample size 2 only, and we took various samples, calculated the mean, plotted them over here. Okay. We increased the sample size to 5. Now just see that these figures have changed to some bell kind of shape, right? Some bell shape has developed, emerged. And when the sample size was further increased to 30, it is almost near to normal distribution. Okay, this is nothing but central limit theorem, and this is how we use sampling to talk about the population. So what did we take? What did we learn from that figure is, if we draw a sample which is large enough, means 30 or more than that, then it is highly likely to be a part of a normal distribution. Right? That sampling distribution was normal in that case. The mean of this sampling distribution matches with the mean of population. This is another property. whatever sampling distribution will be there, okay, since it is a distribution, it is collection of numbers, it will have some mean. So mean of this collection of numbers is equal to the mean of population. This is very important information, right? Then, yeah, this is nothing but the.
But sir, if he takes a sample of two uncommon things like a daily wage earner and an industry profession, then the mean will be very high. But that will not give a
Mean gap will be very high, but that's why if you are taking a larger sample size of say 30 and the whole process is random, then it will be very rare that you meet only 30 daily wage earners. It will be very rare. When the sample size will increase, the distribution of participants will also be different. So what central limit theorem says is that mean of that sampling distribution where sample size is more than 30 or 30 will be equal to population mean, okay, and the standard deviation of that sampling distribution will be equal to population standard deviation divided by the square root n. N is nothing but sample size over here. What I am trying to make out over here is that we have a mechanism that if we will take a sample of say 30 or more, then this sample, this data is part of something which is called as normal distribution curve. And properties of that curve are these. Mu is this and the standard deviation is this. Using these two things, we can do wonders. Okay, we will see how.
Yeah, 30 is the indicative number.
See, we got a bell-shaped curve at n equal to 5. Now somehow 30 remains the magical number where it is assumed that normal distribution will be achieved, right?
Close to normal. Higher the
Yes.
data size.
And then we have proper formulas which will tell you that at least you should have this much of your sample size to assume that the data is distributed in a normal fashion. We have separate formulas for that. But at n equal to 30, what the point I was trying to make is that all the data, whatever be the population distribution, all the data was very near to normal distribution. Okay.
Standard deviation is standard deviation by root of n minus 1? Or
No. When
sometimes we do n minus 1.
we will do n minus 1 when we are calculating standard deviation for sample only.
Okay.
But this is sampling distribution.
Okay.
But let's say for stock market data, what is the sample size? What should be the sample size?
If we are assuming that the stock market, say you are talking about returns. If we are assuming that returns are normally distributed, which is not at all the case, okay, then there is a formula to calculate the sample size for that scenario. That I will share the formula with you. Okay, that is there.
And then generally we will try to find out the outliers.
Yes.
Automatically.
Yes. There is again a debate to it. If we will reject the outliers, it means we are rejecting the important information, right? So
we have a separate process for lab analysis.
yes, yes. So
market is all about the tails. To remove the outliers, you remove the tails. What is left is apparently normal data, which is not normal.
We want normality. Otherwise, statistics will
Market doesn't work like that.
So eliminate the outliers, not extreme outliers.
Skew the data, it will not be the
For
real.
example, 15 years data, you have 0.6, 1 point, another minus 0.6. Out of 252 distribution average, how many times you will have that 0.6 and minus 0.6?
See, the simple thing is larger the data set, the more closer it will be to reality.
That's right.
So yeah. Okay. So since we now believe that sample is capable of taking us to, in a scientific way, to population, right? We have tools like central limit theorem, and we have seen that chart also, which gives us proper faith into whatever central limit theorem says. So now the thing is, if we have a sample and say sample of heights of Punjabi people, right? So usually we have a notion that their height is higher, or someone may have a notion that their height is at least not equal to the average height of the country, right? So if that notion is there, how do we write it in a form of hypothesis? This is the way to write it in the form of hypothesis. And obviously we won't meet all the Punjabis, measure their heights and then check. What we will do is we will take a sample of Punjabis and then do this study, right? So first of all, we must know how to write the hypothesis. So as seen in this, there are always two statements in the hypothesis. One is null hypothesis and another is alternative hypothesis. Now, there are various ways to say that what is null hypothesis and all. But there is only one way to tell what null hypothesis is. The statement which has equal to sign is null hypothesis. Mathematically, that is null hypothesis, right? And if you will learn about various inferences, how to write those statements, ultimately you will also agree something that yes, null hypothesis means equal to sign should be there. Okay. Null is something. Null is where equal to sign is.
Okay. Null is something that the researcher will not let go until and unless the result from the proof from the sample indicates otherwise. Null is a statement that the researcher will stick on to till the evidence from the sample so strongly contradicts it.
That also depends on how you state the problem.
Okay. Okay. Again. All the discussions will come after 5. Okay. We are very strict on time now. So the thing is, as I said, everyone will have different opinions, but no one can deny that equal to sign is to be there in the null hypothesis. I am telling it in a very crude way. That may sound bad, but that is the truth. Okay. So if we are testing whether Punjabis have height equal to the national average of say 5'5". Okay. So what we are testing, whether Punjabi's height is equal to national average. Height equal to national average. Wheresoever equal to is there, that will become your null hypothesis. And how will you measure the height? You will take average of the heights of Punjabi sample, right? So average means again mu. What you are trying to predict is population's average for Punjabis is equal to nationwide average heights, right? So this becomes your null hypothesis, and what will be alternate just opposite of it? Once you have written null hypothesis, just opposite of it is alternate hypothesis. Again, I am sounding very crude, but this is how you can remember it forever, right? So mu not equal to not equal to. If someone would have had the hypothesis that Punjabis have higher heights, okay, higher heights means, see, equal to will be there. I told you equal to will be there. Higher heights means greater than. What is opposite of greater than equal to? Right? So I am sharing you. It will be there in the PPT. PPT will be there. PPT will come to you through mail or something. So in that there is name of one book, Anderson Sweeney. Easily available, very good book. Refer it. Lifelong help for you. Anderson Sweeney. It will be there in some slide. That can be remember now. So this is how we write hypothesis. There needs to be some value in hypothesis. are situations when we might be testing correlations or relationships, right? That time these will not come, right? When relationships are tested, either two things are related or not related. That time you are free to write the null hypothesis and alternate hypothesis in the form of words, right? Then whatever we do for hypothesis testing, our sample needs to follow a distribution. Again, central limit theorem comes to help us over here. If sample size is more than 30, it will follow a bell-shaped curve. It may be normal distribution, maybe t-distribution. Okay. It may be any other distribution. Maybe you are just checking genders. Okay, zeros and ones. Zero means male and one means female. Females are always one step ahead. Okay, that's male 0, females 1. Whenever say it is the case of gender, the mean of male genders will be what? 0 plus 0 n times divided by n will be 0, something like, okay. What will be the standard deviation? Again 0, okay. So in those cases where standard deviation and mean doesn't make any sense, not use parametric tests. In those cases we will use non-parametric tests, but those non-parametric tests also have some distribution. Do remember it. In order to find out which of these statements is true, we will always have some distribution to follow. Who of those distributions I will just tell you in a minute. Ma'am, just tell me when that guy comes. No? Everyone is waiting for that tea break. Even I am waiting. Now, when we do hypothesis testing, whenever you would have come across some statistical data, there would have been these two things, alpha and p value. Right? And once we crack them, then they are gone forever. Otherwise, they will always haunt us. Okay. In fact, a very learned person who was doing business analytics at Infosys, he called me just to understand what is p value and what is alpha. Okay. He knew all the codes. He could do very good analysis on big data. But someone asked him to do this logistic regression. That also he could see in YouTube and all and do it. Then in the end he got p values, alpha, all these things. So he was not able to understand what is this. Okay. So looking at this, p value and alpha, what this chart is trying to tell you is about type 1 error and type 2 error. Okay. Now look at these statements, null hypothesis and alternate hypothesis. We don't know which one is true, but we will gather some data from sample, do some testing and try to find out which of them is true. Okay. How to do that? Just we will see in a moment. But there are possibilities of making two errors. Okay. One error is HO was true, but we rejected HO. It means height of Punjabis was greater than equal to national average, but we rejected this statement somehow. Some wrong calculations, biased sample, whatsoever it might be. This was true, but we rejected it. This is called as type 1 error. Okay. Then, when this was true, height of Punjabis was less than the national average. Okay. But we accepted this, or let us say this was true, but we rejected this. This is called type 2 error. Very simple. Type 1 error is related to this line. Okay. Null hypothesis. And type 2 error is related to alternate hypothesis. You can twist these statements in n number of ways to confuse yourself. Okay. Right? But this is the ultimate graph to tell you what is type 1 error, type 2 error. And what I told you right now, when this is correct and you reject it, this is type 1 error. Okay. And when this is correct and you reject it, this is type 2 error. Very simple. Very simple. This is what is written over there. And then you can, keep on confusing it the way you want. Now, somehow, type 1 error is something which we don't want in most of the studies. Somehow, okay? What is that somehow? We have come to study over here business analytics, business world, right? It has been seen in various researches and studies that type 1 error is very costly, very costly. Suppose right now my firm is working very well. I am earning 20% profit. Okay. Now someone comes with a plan, said do these things. Okay. And then profit will increase to 21%. Both of these numbers will be same. Okay. So someone comes with a plan that profit will increase. In order to follow that plan, there will be some cost associated. That plan will not be for free. Some investment, something will be there. Okay. Now, if that plan fails, right? Okay, the plan was brought in, and then again the data was collected. Since sample was collected, we did a hypothesis test. The test will be like this only, that profit is now improved to 21%, or profit is not equal to 21%. Can be something like this. Okay. The question is, if this is true and you reject it, the profit did improve, but you rejected it, then you are going back to 20%, right? You are losing on 1%, right? Another way to look at it, which will be very related. What does court assume for individuals when they appear in court? What does court assume?
They are innocent
till proven guilty, right? Court assumes that they are innocent. The null hypothesis of court is that whosoever comes in court is innocent, right? Suppose you were innocent, but wrongly charged and you were proven guilty, right? Can you see the cost associated with it? Okay, so we can understand that there is some cost associated with breaking the status quo. Okay, and we should not break the status quo until and unless we are very sure that if we will break the status quo, it will be all good and better, right? That's why type 1 error is very critical, more critical than type 2 error. Type 2 error, for your sake of information, is very important in clinical studies, right? You can infer the reasons for that. Now, since we are interested for type 1 error only, here comes the alpha and p value. When you are looking for rejecting null hypothesis, alpha is the allowed probability of making type 1 error. Suppose I am interested to check whether I can reject the null hypothesis or not. Okay. When I will reject the null hypothesis, rejecting the null hypothesis when it is really true, what error I may make is type 1 error. Okay. The allowed limit to make the type 1 error is alpha.
The same as P stat.
Any statistics, any test, the allowed limit to make type 1 error is alpha. Okay. Okay, this is the allowed limit. That will be decided by some better researcher, or when you will become a better researcher, you will decide it. Okay. Usually it is 5%. Okay. Now, what is p value? alpha was given randomly by some good researcher that take it 5%. What is p-value? You have your own data. Okay, you are putting that data for putting that data to test for hypothesis testing. It will give you some results. Of those results, there will be one p-value also, which is nothing but when you are testing a hypothesis on your data and you are trying to reject null hypothesis, p-value is the probability of making type 1 error as per your data. Alpha was allowed, p-value is as per your data. Now you tell me, if you want to reject this null hypothesis, p-value should be more than alpha or less than alpha, right? Because we want to reject, but error which we want to make should be less than alpha. If the error is less than alpha, then only we are happy to reject the null hypothesis. Again, let me tell you, this is very crude way of looking at it, but it is also one of the correct ways. Okay, and why I chose this way? Because there are people who don't understand p-value and alpha, right? In our team, but they are very good programmers or they are very good analysts also, right? So this statistics should not hinder upon their creativity. That I made it simpler. That alpha is the allowed limit of error. The amount of type 1 error which your data is making. If your data is making less error than the allowed limit, then you can reject the null hypothesis. This is what this discussion was trying to come up with. This is a slide which says that why type 1 error only. I already discussed that. One more thing, why type 1 error only? At this level of alpha, 5%, we are actually controlling type 2 error also. This is like optimal point where we are in a proper way controlling type 2 error also and type 1 error also. If we are still further reducing type 1 error, then we will increase the chances to make type 2 error. This is how, but this 5% is the balancing figure. That's why in most of the studies you will see 5%. So now I will skip this and we will start the test. Okay. Okay. Yeah, we are breaking body and you can ask the question. Correlation is also allowed. We just need to check whether that correlation is 0 or not. If it is 0, then it means no relationship, right? That will be the hypothesis in that case. Is the correlation equal to 0? Yes. But the thing is, both of these variables should be numerical to calculate Pearson correlation. If they are categorical, then we will have to use scale and rank correlation, something like that. Yes, we will do it. To reject. Generally, no, not generally. Everything.
You talk about predictability. Then you want to you can't predict the actual value.
Regression works. Regression works only with parameters. Exponent is continuation with a normal range.
Right. Otherwise,
Yes, you won't get the false values. The beginning doesn't have regression to point anywhere. That means that you have a prediction power. Right. You're predicting wrongly.
there's no actual.
That's what.
All programming, all stats.
Data should not be distributed. And also not there is a serial
Okay, so when we talk about hypothesis testing, we have these two kinds of tests, parametric test and non-parametric test. Okay, and basically the difference between them is, or the ease of understanding. These are dependent upon your kind of data. Okay, if the data has interval or ratio scale data, interval or ratio means in SPSS we used to say that numerical data, right? Or data which is in numbers, plain numbers which can be added, subtracted, multiplied, divided. If that kind of data is there, we will use parametric tests. But as I said, we have data like gender. We have data like occupation can be there. It can be like simple names, right? Tomorrow we will have a session of text analytics where we will have only words, and you have to make some sense of those words, right? So one way could be simply to count them, right? Of a basket of some 10,000 words, which words are occurring most frequently is also an information, right? So if we had some hypothesis over there also, those kind of data, we have means to do hypothesis testing over there using non-parametric test. As I told you in the previous slide, in order to do a hypothesis testing, we need a sampling distribution. If we don't have the sampling distribution, we won't be able to do the hypothesis testing. So depending upon the kind of data we have, we will have the related sampling distribution. Then we will decide to use parametric test or non-parametric test. So in this PPT, I have given one link also. There you can see the difference between the two in details. Right? One good thing you can note over here that in non-parametric areas, we will use median, not the mean. Mean is sum of all the numbers divided by total number of observations. Okay. Now, can you add names? Can you add zeros and ones, which represent gender, right? So, since addition cannot be done, that's why we are using median over here. And what is median? Median is the point in which 50% of the data is covered, right? That's how it is said to be the central point. Okay. So, given all those things, let us move ahead. The point which I wanted to make is, given the kind of data, we have a kind of test. Okay. So we should apply that kind of test only to get a proper hypothesis testing result. So which test should be applied in which scenario? Again, this is a table available at this link. And suppose we want to compare locations. Locations means what? Median, I told you. Mid location. Average is also supposed to be in center of the data. Location. Okay. So location means nothing but mean, median, and mode. Suppose you want to compare the means. Then again, when I say mean, you can make it out that it is for numerical data. Okay. So it should use parametric test, and that test will be one sample t-test if we are comparing means. Suppose I want to compare two means from independent samples. One example could be marks of students in section 10A and marks of students in section 10B. Okay. So different students, independent performance, their performance was not dependent on them and their performance was not dependent on them. Right? So if I want to compare the performance of these two classes, so I can compare their means by using t-test on two independent samples. Then whether the means are equal and it will be somehow it is missing. Again, we have some tests for that also, but this is for C. Sorry, what I wanted to say is we want to compare two means. If we wanted to compare two medians, so man-based YT test is there, right? So this table is very useful for those who want to look at this process in a mechanical way. That if I have this kind of data and I want to test this, so which test should I apply, right? So go and get this table. You will get a proper list. If this kind of data is there, this question is there, this test has to be applied. What will be the R code for that? It is also there in this slide, okay, this PPT. So let us start with this exercise. Everyone might be having a folder named hypothesis 1 or hypo 1, something like that. Everyone has that? Hypothesis 1 and 2. So right now we are interested in hypothesis 1 folder. In that there should be a file named cs2m.csv. Before doing anything, what will you do with cs2m.csv? You will get that data in your R environment, right? And how to get that data, Rajat sir has already told you. We are interested for hypothesis 1 folder, hypo 1 or something like that.
Which is the files?
CS2M. Now, the whole activity is mentioned over here. Okay. I am not showing you our script window. You have already seen it. You have already run a code to import the data. So import the data. Import the data with this name. Hypo 1. Extract. It can be Excel file, but then it will be imported in a different way. When you are importing that file, what are you able to see? Okay, who has not got that file yet?
What is file?
Everyone has got that file. When you will import it, you will be able to see 30 observations of 6 variables, right? That came. Okay, everyone got it? The one who has not got it, please raise your hands. Now, after importing, you have to simply run this command. Using this command, what we are trying to do is, just look over here 2 minutes. We are trying to test this null hypothesis that mean age of our data is equal to 40. This is what we are trying to test. Now, how to test that? So we will use one sample t-test. Okay, and then what is the syntax of this function, t-test function? T.test in parenthesis ch2m $age. Why ch2m $age? See, age is the variable we are interested in. Now the question is, many of you might have imported it into data. Data is equal to something something, right? At that time, don't use ch2m. Now your data is stored under which name? Name data. So it will be data $age. Okay. And what we want to check is, do you remember I had written mu over here? Mu is equal to something something. So we want to check whether mu is equal to 40 or not. That's why we are typing mu equal to 40. Is it working? You have stored as data. You brought the data and stored with the name data. So over here data $age. Okay, if the test is not working, then there is also one more reason. Maybe you are missing a package. Okay. This, no one got this? Got it? But don't use this here, you got the data in the See, excuse me. This is denoting if you are writing this code in console. See, there were 4 windows. One was where you were writing, then output was coming in the second window. In that second window, each and every time is starting with this. Yes? So you can also check your command in console. If it is working, then only you put it in your script. So that's why this is there. But if you are writing in script, just don't write it. Just don't write it. Write only this much. Okay. Now it is working. Great. Those who have done it, those who have done it, go for this. Just a second. Those who have done the previous exercise, import grades.csv. Okay. Those who have done the previous exercise, import grades.csv. Then we will do the next exercise. Okay. Yeah. I'll do this. I want every one of you to get this output.
Which file was that one?
Next one, grades.csv.
Grades.csv.
For next exercise, it is grades.csv. This output must be there. After doing this exercise, after putting this function, this output must be there. Don't put this. This is for console. Grades in that. See, those who are able to do it quickly, just open the presentation which is there in hypothesis 1 folder. Okay? Use that presentation and move around. Open the hypothesis 1 presentation, and you can, in your self-learning mode, you can keep on doing the further exercises. For t-test it is this, t.test, student dollar.
You are rejecting the null.
See, I told so many times that when you are writing in a script window, don't write this greater than sign. Okay? And you got the data with the name data. Okay, so it should be data.
Outside the this will be lower than
now let us look over here.
Less than the.
As I see that all of you have got this output. Okay. Now what was our test over here? Our test was null hypothesis. Mean age is equal to 40. What would have been alternate? Not equal to 40, just opposite of whatever is written in null hypothesis statement. So we did a t-test for this. Why? Because we are comparing a single mean, one sample t-test we did. How we did it? We used this function, t.test function. Okay. Okay. Why its name is T dot test? T represents the distribution, T distribution, and we are trying to test the hypothesis. Hence, it was named as T dot test. Since it is a function, it will have brackets, normal brackets, parentheses, and this is the name of the variable on which we want to test. How to pick the correct name? Some of you now, everyone don't do anything on your laptops, please, right? Those who could not get it, especially those ones. Many of you imported the data as data equal to read.csv and so on, right? So all your data was imported with the name data. Had I not done this, my data would have been imported with the name of the file only, which is cs2. Okay, but since in the previous session you had learned that we have to import data as data equal to something, that's why many of you did this. Data equal to read.csv. Now your data is under this name, data, and you want to pick what of this data? Age. So then it will not be cs2m$age, it will be data$age. Okay, and what we are testing upon is mu is equal to 40. Had it been greater than equal to 40, you put greater than equal to 40, less than equal to, you put over there less than equal to 40. Then you got this output. Okay. The first thing is what this output is. So this variable. Then what was the t value? Those who know t distribution, degrees of freedom and all, they will understand what this value is. Okay. Those who don't know it, frankly speaking, need not to know it. Okay. Because our simple interest was whensoever alpha p value is less than alpha, we will reject null hypothesis. And when we are not able to reject null hypothesis, we will accept null hypothesis. Simple. Only two ways we can move ahead. Here p value is 0.5203, which is nothing but 52%. And alpha usually is 5%, right? Just before the t we had discussed. So 52% is way higher than 5%. Can you reject null hypothesis over here? So you can accept null hypothesis. So as per our data, mean age is 40. Got it? As per our data, mean age is 40. Now, one funny thing, since many of you are totally new to statistics, if you will do this test with mean age equal to 39, most probably still the null hypothesis will be accepted. If you will do this test with mean age equal to 42 or maybe 38 also, this hypothesis may get accepted. What does that mean? That simply means we are doing sample study. We are using laws of probability to talk about population. So probability is what? It won't give you a certain answer. It will give you answers in some range or something, or this is also true, this is also true, something like that. Okay? But beyond this, no, boss, this is wrong. Something like that will happen. Because we are talking in probabilistic manner, not deterministic manner. That's why this deviation will be there. Don't get worried, that you are doing something wrong. Okay, so it gives the result also. Alternate hypothesis, true mean is not equal to 40. Okay, it gave that which statement is true. It gave the result. Alternate hypothesis is rejected. This is accepted. This is rejected. This is what it gives. And then there is something called as confidence interval. Those who understand statistics, they can understand this. Others can Google it. Then mean of actual mean. What is actual mean of the data? 37.76. I told you that if you will pick 38, maybe the null hypothesis can get accepted. It will move highly, most probabilistically it will get accepted because the mean is 37.76 of the data, right? So moving ahead, this is second kind of test, paired sample t-test. What do we mean by paired sample?
Same samples that we are collecting two different times.
For same sample, two different kind of data.
Different periods.
Periods.
Before and after.
Before and after. Yes, this can be one case. For same data set means same IDs, same persons. Okay, we are collecting same kind of data set, not different. We will never compare apples and oranges. Okay, because everyone knows apple is different than orange, right? We need not to compare. So, as they said, before and after can be one case. Like when the new teacher came, did the score of the class improve in mathematics? So before, what was the score? After, what is the score? Obviously, students will be the same, right? If we want to compare those kind of things, right? How we will do that? Just, I am giving you background of how it is done. Say we have 4 students. Before they had some marks. After the new teacher was introduced, again a test was taken and then new marks were counted. It is very obvious that new test will be of those 20 marks only if the previous test was also of 20 marks. Okay. Suppose this is the data set after new teacher, right? Now, can I make a third column named difference? So this will be 16 minus 15, 1, 0, 0, 1. Okay. Now, if I have numbers, let me make it 17. Let us not make it look like binary numbers. Okay. If I have numbers which can be added, subtracted, multiplied, divided, so I can get the mean of these numbers. Can I? Yes. If I can get mean, I can get the standard deviation also. And if I can get these two things, I can do our one sample t-test. This one sample t-test was also based upon mean and standard deviation only. In background, this was only happening, right? So here we had a column of age of various observations, and we calculated the mean and standard deviation and did the hypothesis testing. Here I have 2 columns of data, but I converted that into one column, and I will have a hypothesis whether this difference is equal to 0 or not. If the difference is equal to 0, it means the new teacher did not make any improvement, right? And if it is not equal to 0, then we will find out what is the average score over here and what is the average score over here. If the average score is improving, then we will say that new teacher made difference. Okay. So same technique but applied to a different column set becomes paired sample t-test. And how to do this? So everyone on your R script window, import this file and apply this test. This time you should not make that mistake. If you are importing with data, then put data over here. Okay? And know this greater than sign over there, because this represents console. Those who have done this may go to the next one, independent sample t-test. I am putting this slide over here. Follow this one. This is easiest. Since we have less time, so follow this one. This is easier. This grades got CSP. And if you have done this already, then you did. Sir, open the PPT inside the hypothesis one folder. Yeah. there is one PPT with every one hypothesis, one code. Use that PPT and keep on moving ahead.
It's not working, right?
Allowed error. Alpha is allowed error. Okay, P value is the error which your data is now. Redistribution other. Depends, but most of the time it is fine. If in every case it will be given that alpha is fine. It is less than alpha, it means what we can do, we can reject it. आपका allowed error जो है, आप इसके अंदर ही अंदर error कर रहे हो. Allowed error for what? For rejecting nothing. See, we are nearly one session behind our schedule. So tomorrow by 8:45, everyone should be over here. And when you all have all the material with you, right? Practice it at your home. Whatever doubts are there, if you can come a bit early, we will solve those doubts tomorrow. Just a second. Don't put this. If you want detailed interpretation of this, or proper degree of freedom. Not this is not percentage, this is degree of freedom. Area will be area in the N minus sample size minus. So what? In this case, degree of freedom is 1 0. Everyone got this output? Those who are getting the output immediately try the next slide. Slide is
with you only.
Rates not formed.
More than the significance, more than the 5%. If it is more than 5%, then you cannot reject the null. That means you have to accept the null. I remember it. It's the low the exception. Reject the null.
Okay, so now since everyone has got this output, our null hypothesis is that difference is equal to 0. Difference of quiz 1 and quiz 2, okay, is equal to 0. That this is our null hypothesis written over here. Our sample is paired. That's why we made paired equal to T. Try to read the syntax, means the flow, how this has been written. Okay. So we were doing T test only, T dot test. We are doing this test now on two variables. Which are those two variables? Quiz 1 and quiz 2. And what do we want to? How do we want to conduct this test? We want to pair them, match them as per the data ID. Okay, that's why we did paired equal to T, and we got this output. Output is P value equal to 0.004. Now this try to focus over here. P value is 0.004. It means it is, suppose alpha is equal to 5%. It is less than alpha, right? The error, the probability of making type 1 error as per my data set is 0.0049, which is lower than the allowed range, which is 5%, 0.05. So in this case, what we will do? Reject the null hypothesis. So what is null hypothesis? That there is no difference, or difference is equal to 0. Okay, so we will reject it. Okay, rejecting means there is some difference. Difference is not equal to 0. What is the difference? Minus 0.51. What is that mean difference? Minus 0.51. It is given in the output only. What does that mean? When can a negative difference come? When the mean of quiz 2 is higher than mean of quiz 1. It means performance has improved. Okay. Later on they are having better performance. That's why negative mean is
coming. Okay, this is how we will infer this output.
The syntax of paired equal to t means the null is 0.
Paired, we want to pair the data.
Yeah, so when you say paired equal to t, that means that both are equal.
Paired means, see, these are the IDs, roll numbers of students. We want 3 in quiz 2 should be paired with 3 in quiz 1. That's how we want to do the pairing. Same respondents' values should be paired together. Okay.
No. So what I'm asking is, does the syntax by default imply that your null hypothesis is 0?
Yes. Yes. Correct.
Can we mix more with like more variable also?
See, we have a good question over here. Everyone, please focus upon. Excuse me. There is a question that can we have more than 2 variables? Yes, we can have. We can have n variables, but that at that time we will use ANOVA. Okay. That time we won't be using t-test. T-test is only for 2 variables. Okay. So quickly, let us do this test now. Now we are trying to do independent sample t-test. We are trying to do independent sample t-test on our file cs2m.csv. What is independent sample? See, if you will see this cs2m file. It has a column named blood pressure and another column named anxiety. Does it? It has this cs2m. Just open that file in Excel or whatsoever. Just try to view the data. It will have blood pressure and anxiety level. It has. What are the values in anxiety level column? Zeros and ones. So over there, 1 represents high anxiety and 0 represents low anxiety or same amount of anxiety, right? So what we want to check over here is very interesting thing, that does blood pressure differ for different anxiety levels. For people with same anxiety levels, there will be some blood pressure level, mean blood pressure. With people of higher anxiety levels, which is 1, there will be some mean blood pressure. Are these two means equal or not? This is our motive of testing the hypothesis. Okay. Now again, these two are independent samples or not? Someone having low anxiety, someone having high anxiety, until and unless they are married, they are independent samples, right or not? Right? So, because when they are married, they will say that my anxiety level is higher because of my spouse, right? So, so given that in our sample none of them is married, we can assume that these are independent samples. And then how to do the t-test over there? So this is the way to do the t-test over there. Very simple. We want to do t-test. This is blood pressure, and we want to segregate this data based upon anxiety levels. So this tilde sign, okay, this tilde represents that we want this data to be segregated based upon anxiety levels. Now be very careful when you are using tilde sign over here. This data should be in the form of zeros and ones or in categorical form, right? It should be able to split the data into categories. Okay, and when we are doing t-test, we can have nothing more than 2 categories. Okay, so this data should be binary. Please do this test hands-on. Again, you must store the data somewhere. Okay, after reading, store it somewhere. After storing, whatever name you have given should come over here, and don't use this sign if you are working in R script. This will be automatically there in the console. Do not get worried. All of you are doing very well. In my first day of doing R, I could not do anything. Okay, I could just read a file. Null hypothesis that there is no difference. It means there is difference. See the next slide of ANOVA. What you were telling me that we have 3 more categories. Everyone must get this out.
Actually, for this, because we are restricted to this file. So here again we have to choose this file, then only we are getting on.
Yes. See this slide is self-explanatory. Okay. It says file this. It means read this file. Okay. It says that this is the null hypothesis. This is the test, and you will get this out. The only thing which may not match is this and the name of your data. Put the address of that file in inverted commas, it will read that. When you are reading it, it is equal to something, it will store in that way. Okay. I find that still some 3 or 4 of you are struggling to read the data. Okay.
Yes.
So I am showing a very simple way to read the data. All of you just look over here. One simple and final shot to understand how to read the data. Okay. Rajat sir, I am solving your problem. Just look over here, right? The best way before starting your analysis project is to declare a working directory. Okay? Just declare that this is the address where I will keep all my data, where I will save all my output. Working directory means nothing but a folder in Windows. Okay? So I have created a folder. Okay? The address of that folder is this: C, users, Abhishek, document, sign, nurture, MDP, FDP, study material, hypothesis testing, hypo 1. Need not to worry whatever be the address. Just copy it, paste it, and change the single forward slashes into double forward slashes. Right? Inverted commas, set WD. This is the function. This is the place where all my data is there, and where if I will produce any output and want to save it, I will save it at that place only. Okay, all of you are using hypo1 folder only. You can get that location, put that inside the brackets for setwd command. So it will set that folder as your working directory. This is the place where all the files are there. Okay, this is step number 1. Step number 2 is simply whatever you want to read, whichsoever CSV file you want to read. Now you need not to give the address inside the bracket of this function read.csv. Otherwise you were giving the whole address. No, now you need not to give because the folder has already been set. Okay. Now the moment I will type this, what will the R do? R will read it and tell me that this file has 30 observations of 6 variables. This it will tell me. But have I saved it anywhere so that I can use it, retrieve it? No. So for the sake of identification, I will save with the same name. Now it will be saved somewhere. It has been saved with the same name, right? I have given the same name. It has been saved again with the same name. Okay. And now I can. Now if I want to call one of these variables, you know the trick. Use the $sign and call the variable. Okay. Again, set working directory. Put the address of your folder where all the files are there, and then import whichever file you want to import. All the time you won't have to put the address. Whatever files are there in that folder, they will be imported by simply giving the name of that file in the brackets. Your chances of making errors will also reduce. Then let us go back to our exercise. Who has not got this output? Have you got it over there? Last. Yes. For that, you will have to call one library package. You will have to install one package. Then it will, by default, it will accept CSV. Okay, so now let us understand this output. So our null hypothesis was that mean blood pressure is same across anxiety levels. Okay, means when anxiety level of a patient is high, whatever be the blood pressure will be same as blood pressure of person with lower anxiety level. Okay, this was our hypothesis test. What is the output? Output is p value is equal to 0.01268. Now p value is less than alpha, say alpha is 5%, which means that null hypothesis is rejected, or blood pressure is not same across anxiety levels. Okay, we don't know whether people having higher anxiety have higher blood pressure or what, but it is not same across anxiety levels. This is what we come to know. So what is the truth in the data? This is the truth. Mean in group 0, group with lower anxiety levels, has mean blood pressure of 170. Then mean in group 1, higher anxiety levels, mean blood pressure of 138. Way more than, I think 120 is supposed to be the ideal, right? So those who have lower anxiety levels or no critical or dangerous anxiety, they have optimum blood pressure. Those who have tension in their heads, anxiety, they have higher blood pressure levels. Okay. Now tell me, if you are given slides like this, will you be able to do rest of the test by yourself? Right? Because everyone will agree that in these 3 days we cannot teach you everything. Okay? But you should also agree, after looking at the material, that we have provided you a lot, which will help you in most of your real life exercises, right? So I have one-way ANOVA and proportion test. Then, as I said, non-parametric test. Same things done for median. I have everything. Everything is the same format. The file name is given, null hypothesis is given, the function which you have to run is given, and then the output is also given. It is true that interpretation I have shared here in the class. Okay. But if you want to Google it, you will get that interpretation in seconds. Even if you don't want to do that, if you don't want to, if you want to save your time in Googling, look at this table. All these tests, when you will click upon them, you will get all the details, how to interpret and all. Okay? So this PPT might not be with you. I will share it with you, no problem. Okay? It has been my practice the moment I got to know what kind of batch will be coming from for MDP or MDP. That way only I prepare the PPT. So in this PPT, my thrust was to connect this that story, that sample can lead you towards population. And when it leads you over there, there is something called as hypothesis testing which has to be done. And it is done using only two numbers, alpha and p value. There are many other numbers, they have their own meanings. But in order to make sense of these two statements, p value and alpha will suffice, right? So using that, and then I wanted to tell you there are two things in the world, parametric test and non-parametric test. Why two things? Because there are two kinds of data in the world, right? Quantitative or qualitative, or metric, non-metric, whatever you call it, right? So for that we have two different kinds of tests. How to do that in R? We have very simple slides. The steps are like this: import the file. This is the test. This is the command, and check the result. 4 steps. You will learn the test. Interpretation. Use this. You will get the interpretation also. Okay. This is developed by Microsoft. Excel stat is there, right? Someone would have used it, right? I have taken it from there, so very authentic also. This is all for today. Those who will come up with good questions tomorrow, we will have some small token chocolates and all for them. And next tomorrow I will take session on text analytics, and Rajat sir will take other sessions also. Right now Rajat sir will continue with regression. Okay. So thank you. We will have this session now. See, we are ready to extend. I know the time was till 5 only. So we are ready to extend. Those who want to extend it, please let me know. Or we will somehow try to accommodate it tomorrow. The chance is something might be missed. Okay. most probably we will try to, do it as quick as possible.
Multiple regression.
Tomorrow.
Okay. But 8:45.
8:45, we have to come in.
Yeah, we have to start it. We will not
So tomorrow what we will do is we will be say stricter and crispier on the brainstorm. Immediately after some 5-10 minutes, we will return back, right? We will do all the talking and networking inside this room.
And I have a special request. Since I've roamed around and I've seen the kind of mistakes that you've done in ours, which is very likely is like in coding you are really struggling. So please, practice it today. And the name that I keep giving data, you please change your name and give that. Okay? Don't put data, and that's where you have struggled. Yes, I was, importing those files as CS2M, but we were doing it in data, and we kept giving CS2M in the R, and R never understood what is CS2M. Please, unless and until you practice it tomorrow, regression, you will have multiple codes running. So many codes, you will go mad. So please practice this tonight.
I would like to thank everyone present here, and we would request everyone to come tomorrow to college by 8:45 so that we can start the program early and let it be informative at the same time. Thank you. And please make sure you don't leave anything behind. Make sure you pack everything, all the necessary items that you got. Thank you.
See, we have shared a lot of material with you. It is for your personal use. Okay? You can share it wheresoever you want to share it, but it is a request that acknowledge, whosoever has made that material.